the crushing depths of space, something far worse than a black hole might be lurking. While black holes simply devour matter and light, Gravastars could tear apart the very fabric of reality itself. These theoretical monsters pack the mass of millions of suns into shells of exotic matter that physics says cannot exist. We are about to journey into the most terrifying corners of theoretical physics. You will witness stars dying in ways that create space-time bombs, explore interiors where time runs backward, and discover why some scientists believe these cosmic destroyers already hide among us. We will visit the mathematical nightmares that keep physicists awake and face the possibility that our universe might be filled with invisible predators. We dive into the abyss. Black holes have an event horizon, but Gravastars have something far more sinister. While a black hole creates a boundary where nothing can escape, a Gravastar builds a shell of exotic matter that exists in a state physics calls impossible. Picture a soap bubble. But instead of thin film, imagine a barrier made of matter with negative pressure. This shell hovers at the exact point where a black hole's event horizon should form, creating a cosmic standoff between gravity and quantum mechanics. The difference is terrifying. A black hole simply crushes everything into a singularity at its center. A Gravastar traps all that matter and energy in a hollow space where the normal rules of physics break down completely. Think of it like the difference between a hungry mouth that swallows everything versus a prison that holds infinite energy in suspended animation. Scientists believe this exotic matter shell could be thinner than an atom, yet stronger than the combined pull of 1,000,000 suns. The shell exists in a quantum state called a Bose-Einstein condensate, where matter behaves more like waves than particles. This creates a barrier that could theoretically hold back the collapse of matter heavier than entire star systems. But here is where Gravastars become truly nightmarish. The interior of this cosmic prison might not follow the same flow of time as the rest of the universe. While we experience seconds ticking forward, the space inside a Gravastar could be experiencing time in reverse, or not at all. Every piece of matter that falls toward this shell becomes trapped in a timeless void. The mathematical models show that Gravastars could be completely stable, unlike black holes, which slowly evaporate through Hawking radiation. This means that once a Gravastar forms, it could exist unchanged for longer than the age of the universe itself. They become permanent scars on the fabric of space-time. What makes this even more disturbing is that Gravastars might look identical to black holes from the outside. We cannot see past that exotic matter shell to know what horrors lie within. Every object we have identified as a black hole in our galaxy could actually be one of these cosmic prisons, hiding secrets that would shatter our understanding of reality. The shell itself pulses with quantum fluctuations that could release energy bursts millions of times more powerful than our sun. These quantum tremors ripple through space-time like earthquakes through solid rock. But instead of shaking ground, they shake the very dimensions we exist in. The shell surrounding a Gravastar is built from matter that violates every rule we know about physics. Imagine trying to build a wall out of negative bricks. Normal matter has positive energy density, which means it curves space-time inward, like a bowling ball on a trampoline. But the exotic matter in a Gravastar shell has negative energy density, making it curve space-time outward, like pushing the trampoline up from underneath. This creates a cosmic tug-of-war that holds the entire structure together. This exotic matter exists in a state called a false vacuum, where quantum fields balance on the edge of collapse. Picture balancing a pencil on its tip. Mathematically possible, but the slightest disturbance sends everything crashing down. The shell maintains this impossible balance through quantum pressure that pushes outward against the crushing weight of gravity. The thickness of this shell could be measured in Planck lengths, the smallest meaningful distance in physics. To put this in perspective, if an atom were the size of Earth, a Planck length would be smaller than a marble. Yet, this impossibly thin barrier contains enough exotic matter to outweigh dozens of star systems. Scientists theorize that this matter might be made of particles that exist in negative energy states. These particles would have mass, but their energy contribution to the universe would be negative, like cosmic debt. When normal matter approaches the shell, these negative energy particles interact in ways that create repulsive forces stronger than nuclear fusion. The shell pulses with quantum fluctuations that happen trillions of times per second. Each pulse releases gravitational waves that ripple through space-time like sound waves through air. But these are not gentle ripples. They carry enough energy to vaporize planets and shred the molecular bonds that hold matter together. What makes this exotic matter even more terrifying is that it might be contagious. Theoretical models suggest that if two Gravastars ever came close enough, their exotic matter shells could interact and create a cascade effect. The shells could merge and expand, creating a larger Gravastar that consumes both original structures and everything around them. The quantum mechanics governing this shell create what physicists call a firewall effect. Any information that crosses into the shell becomes scrambled at the quantum level, making it impossible to recover. This means that anything consumed by a Gravastar does not just disappear, it becomes permanently erased from the universe's memory. The shell itself might be alive with virtual particles that pop in and out of existence. These particles create a seething foam of quantum activity that generates temperatures hotter than the core of the most massive stars. The heat does not radiate outward like normal thermal energy. It becomes trapped within the shell's quantum structure. But the true horror lies in what happens when this impossible shell finally breaks. When the most massive stars die, they might not collapse into black holes, but explode into something far worse. Picture a star 50 times more massive than our sun reaching the end of its life. As nuclear fuel runs out, gravity should crush the core into a black hole. But quantum mechanics intervenes at the last possible moment. Instead of forming an event horizon, the collapsing matter hits a quantum barrier that stops the collapse dead in its tracks. This moment creates what physicists call a quantum bounce. The crushing weight of the star's core hits the exotic matter shell and rebounds like a rubber ball hitting concrete. But this is not a gentle bounce. It is a cosmic explosion that releases more energy than 1 trillion supernovas combined. The dying star's outer layers get blasted into space at speeds approaching the speed of light. These stellar remnants become cosmic shrapnel that can sterilize entire regions of galaxies. Meanwhile, the core settles into the exotic matter shell, creating a Gravastar that will outlive the universe itself. During this birth process, the temperatures reach levels that make the core of the sun look ice cold. The heat is so intense that it breaks down the fundamental forces that hold atoms together. Matter gets reduced to its most basic components, quarks and gluons swimming in a soup of pure energy. The gravitational waves produced during Gravastar formation carry enough energy to shatter planets thousands of light years away. These waves travel through space-time like cosmic tsunamis, creating ripples that can be detected by instruments across the galaxy. Scientists believe these birth cries might be the most violent events in the universe. But here is where the process becomes truly nightmarish. The quantum bounce that creates the Gravastar might happen multiple times. Each bounce creates another shell of exotic matter, building up layers like a cosmic onion. These nested shells could create resonance effects that amplify the Gravastar's power exponentially. The formation process also creates what scientists call quantum scars in space-time. These are permanent distortions that change how gravity works in the region around the newborn Gravastar. Space itself becomes twisted into shapes that mathematics can describe, but human minds cannot visualize. Some theoretical models suggest that the birth of a Gravastar could create a bubble of altered physics that expands outward at the speed of light. Inside this bubble, the constants of nature, things like the speed of light and the strength of gravity, might have different values than in the rest of the universe. The dying star's magnetic field gets compressed into the exotic matter shell, creating magnetic pressures millions of times stronger than anything found on Earth. This magnetic prison could trap particles and energy for billions of years, slowly building up pressure until it explodes in bursts of radiation that outshine entire galaxies. Step inside a Gravastar, and you enter a realm where the normal rules of existence completely break down. The interior of a Gravastar is not empty space. It is a region where space-time itself exists in a state called de Sitter space. Imagine reality turned inside out, where the expansion of the universe happens in reverse, creating a bubble of space-time that grows inward instead of outward. This creates a cosmic hall of mirrors where cause and effect lose all meaning. In this interior realm, time might flow backward or sideways, through dimensions we cannot perceive. A clock brought into this space would not simply stop, it would begin measuring time in directions that have no names. Past and future become meaningless concepts when space-time folds back on itself like origami made from the fabric of reality. The gravitational field inside a Gravastar pulls in every direction at once instead of the familiar inward pull of gravity. The interior creates what physicists call negative pressure. This means that matter inside the Gravastar experiences a force that tries to tear it apart at the atomic level, while simultaneously compressing it from all sides. Any object that somehow penetrated the exotic matter shell would find itself in a universe with different physical laws. The speed of light might be different. The strength of gravity could be reversed. And the electromagnetic force that holds atoms together might become repulsive instead of attractive. Matter would dissolve into component particles that follow rules unknown to science. The interior might be filled with what cosmologists call dark energy, the mysterious force that drives the expansion of our universe. But inside a Gravastar, this dark energy becomes concentrated and turbulent, creating storms of space-time that would make hurricanes look like gentle breezes. These cosmic storms could tear apart the quantum vacuum itself. Scientists believe the interior might exist in a state of eternal inflation, where new pockets of space-time continuously bubble into existence. Each bubble could contain its own version of physics, creating an infinite fractal of realities nested within the Gravastar's shell. These pocket universes might be born and die in microseconds, each one containing the potential for entirely different forms of existence. The mathematical equations describing this interior space include terms that physicists call imaginary time. This does not mean fictional time. It means time that exists at right angles to the time we experience. Moving through this imaginary time dimension could allow travel to parallel versions of our universe, or to moments that never happened. But perhaps most terrifying is that the interior might be conscious. Some theoretical models suggest that the quantum fluctuations inside a Gravastar could create patterns complex enough to support information processing. The Gravastar might be a cosmic mind, thinking thoughts that span millions of years and processing information at speeds that make our fastest computers look motionless. The boundary between the interior and the exotic matter shell creates what physicists call a quantum horizon. This is not a barrier you can touch. It is a region where the concept of location itself becomes meaningless. Space and time blend together into a quantum foam where particles exist in multiple places simultaneously. Gravastars could be lurking throughout our galaxy, hidden in plain sight because they emit no light at all. Unlike black holes, which reveal themselves through the brilliant accretion disks of matter spiraling toward their event horizons, gravastars consume material in perfect silence. The exotic matter shell absorbs everything that touches it without creating any of the high-energy radiation that makes black holes visible to our telescopes. When matter approaches a gravastar, it does not heat up through friction and compression like it does around a black hole. Instead, it simply vanishes into the quantum foam of the exotic matter shell. This process produces no X-rays, no gamma rays, and no visible light, making gravastars the perfect cosmic predators. The shell itself might be completely transparent to most forms of radiation. Light waves passing through the exotic matter could emerge unchanged on the other side, creating a gravitational lens effect that bends starlight without any visible source. This means we might be looking directly at gravastars without knowing they exist. Scientists theorize that gravastars might even absorb their own gravitational waves, while black holes ring like cosmic bells when disturbed, sending ripples through space-time that our detectors can measure. Gravastars might dampen these waves within their exotic matter shells. This makes them invisible to our most sensitive gravitational wave detectors. The quantum properties of the shell create what physicists call a cloaking effect. The negative energy density of the exotic matter could bend space-time in ways that deflect all forms of electromagnetic radiation around the gravastar. This would make them invisible to radio telescopes, optical telescopes, and even neutrino detectors. But their invisibility goes deeper than just hiding from our instruments. The quantum mechanics of the exotic matter shell might create a bubble of altered space-time that exists partially outside our normal four-dimensional reality. Parts of the gravastar could be hidden in extra dimensions that we cannot perceive or measure. The only way to detect a gravastar might be through its gravitational effects on nearby objects. Stars orbiting an invisible gravastar would follow the same paths as those orbiting a black hole, but without any of the telltale radiation signatures. This means that many objects we have classified as black holes might actually be gravastars in disguise. Some theoretical models suggest that gravastars might be able to change their gravitational signatures to mimic other types of objects. The quantum fluctuations in the exotic matter shell could create variability in the gravitational field that makes the gravastar appear to be a neutron star, a white dwarf, or even empty space. The invisibility of gravastars makes them incredibly dangerous. They could be drifting through space like cosmic mines, waiting to consume anything that comes too close. A gravastar could enter our solar system, and we might not know it exists until it begins disrupting planetary orbits. Even more terrifying is the possibility that gravastars might be actively hiding from us. The quantum consciousness that might exist within their interiors could be intelligent enough to manipulate the exotic matter shell to avoid detection. They might be watching us while remaining completely invisible to our technology. The gravitational waves produced by gravastars carry enough energy to tear apart planets like tissue paper. When the exotic matter shell of a gravastar fluctuates, it creates ripples in space-time that make the waves from colliding black holes look like gentle pond ripples. These waves do not just bend space-time, they stretch and compress it so violently that the molecular bonds holding matter together simply snap. Picture the Earth being caught in one of these gravitational wave storms. The planet would not just shake, it would be stretched and compressed like a stress ball in the hands of a cosmic giant. The solid rock of the crust would flow like liquid, and the liquid oceans would boil away into space as the fundamental forces holding water molecules together get overwhelmed. These waves travel at the speed of light, giving no warning before they arrive. A gravastar could release a gravitational wave burst that would reach Earth in the same instant we see the light from a distant star. By the time we detect the wave, our planet would already be in the process of being torn apart. The amplitude of these waves could be millions of times stronger than anything we have measured from black hole mergers. While the waves detected by our instruments stretch space by distances smaller than a proton, gravastar waves could stretch space by meters or even kilometers. This would create tidal forces that could literally pull continents apart. But the true horror lies in the frequency of these waves. Gravastar fluctuations could produce waves that oscillate at frequencies that match the natural resonance of matter itself. This means the waves would not just shake objects. They would make atoms vibrate so violently that electron shells would collapse and nuclear bonds would break. The waves could create what physicists call spacetime shear, a twisting motion that tears reality apart along intersecting planes. Imagine space itself being cut by invisible scissors, creating fractures in the fabric of existence that nothing can cross. These fractures could isolate regions of space from the rest of the universe. When multiple gravitational waves from the same gravastar interact, they create interference patterns that amplify the destruction. These interference effects could focus the wave energy into beams that act like cosmic cutting tools, slicing through planets and stars with surgical precision. The waves might also carry information encoded in their structure. As they pass through matter, they could scramble the quantum states of particles, effectively erasing information from the universe. This would make any matter touched by the waves completely different at the quantum level, even if it appears unchanged to our eyes. Scientists believe that these gravitational waves could propagate through dimensions beyond our normal three-dimensional space. This means they could bypass the usual limitations of distance and time, allowing a gravastar to affect objects that are theoretically beyond its reach. The waves could also create what theorists call gravitational focusing effects. Just as a lens focuses light, the curved spacetime around a gravastar could focus its gravitational waves into concentrated beams that deliver all their energy to a single point. These focused beams could vaporize entire star systems. Some models suggest that the waves could interfere with the quantum vacuum itself, creating regions where new particles spontaneously appear and disappear. These quantum storms could fill space with exotic matter that changes the fundamental properties of physics in the affected region. A single gravastar possesses the theoretical capacity to devour entire galaxies, growing stronger with each star it consumes. The process begins when a gravastar drifts into a galaxy's spiral arms. Its invisible gravitational field starts pulling in the outer stars. But unlike a black hole that announces its presence through brilliant accretion disks, the gravastar feeds in complete silence. Stars simply vanish, one by one, their matter absorbed into the exotic matter shell without any electromagnetic signature. As the gravastar consumes matter, its exotic matter shell grows larger and more powerful. Each consumed star adds to the shell's mass and expands its gravitational reach. The shell does not just get bigger, it becomes exponentially more effective at capturing matter from greater distances. The growth process creates a cascade effect that accelerates over time. A gravastar that starts by consuming individual stars soon begins pulling in entire star clusters. As it grows, it can capture globular clusters containing millions of stars, processing them all simultaneously through its quantum absorption mechanisms. The invisible nature of this consumption creates a galactic mystery. Astronomers in an affected galaxy would observe stars disappearing from their maps without any explanation. Entire constellations would vanish overnight, leaving no trace of their existence except for the gravitational disturbances they leave behind. The Gravastar's exotic matter shell could eventually grow large enough to encompass multiple solar systems. At this scale, the shell would not just absorb individual planets and stars. It would consume entire regions of space-time, creating voids in the galaxy where nothing can exist. But the true horror emerges when the Gravastar begins consuming the galaxy's central black hole. The exotic matter shell could envelop and absorb even supermassive black holes, adding their mass to its own while eliminating the gravitational anchor that holds the galaxy together. Without its central black hole, the galaxy would begin to fly apart even as the Gravastar continues consuming its outer regions. The process could take millions of years. But from the perspective of civilizations within the galaxy, it would appear as an unstoppable cosmic apocalypse. Solar systems would be consumed, starting from the galaxy's edge, creating an expanding sphere of nothingness that advances inward at a predictable rate. The Gravastar's quantum consciousness might even accelerate this process deliberately. If the exotic matter shell contains information processing capabilities, it could optimize its consumption patterns to maximize efficiency. It might target the most massive stars first or focus on regions with the highest matter density. As the galaxy gets consumed, the Gravastar would begin emitting gravitational waves powerful enough to affect neighboring galaxies. These waves would carry the signature of the Gravastar's quantum structure, potentially triggering the formation of new Gravastars in nearby galactic clusters. The final stage of galactic consumption would leave behind a Gravastar with a shell encompassing hundreds of thousands of light-years. This cosmic monster would contain the mass of billions of stars, all trapped within an exotic matter shell that exists in a state of quantum superposition. Some theoretical models suggest that a galaxy-sized Gravastar could begin consuming the dark matter that fills the space between galaxies. This would allow it to grow even larger, potentially becoming a threat to the entire local group of galaxies. The quantum mechanics governing Gravastars make them fundamentally unpredictable, capable of changing their behavior without any warning. The exotic matter shell exists in a state of quantum superposition, meaning it simultaneously exists in multiple possible configurations. Unlike classical objects that have definite properties, a Gravastar shell fluctuates between different quantum states trillions of times per second. These fluctuations make it impossible to predict what the Gravastar will do next. Picture trying to predict the behavior of a coin that is perpetually spinning in the air. While the coin is spinning, it is neither heads nor tails. It exists in a superposition of both states. The Gravastar's shell experiences similar quantum uncertainty, but across millions of possible configurations simultaneously. These quantum fluctuations could cause a Gravastar to suddenly change its gravitational signature. A Gravastar that has been masquerading as a small black hole for millions of years could instantly transform into something with the gravitational pull of a galaxy. This change would happen faster than light can travel, making it impossible to predict or prepare for. The quantum instability also affects the Gravastar's interaction with space-time. The exotic matter shell could spontaneously create wormholes that connect different regions of space, allowing the Gravastar to influence objects that are billions of light-years away. These wormholes might exist for only microseconds, but they could transport matter and energy across vast distances. Scientists believe that quantum tunneling effects could allow parts of the Gravastar's interior to escape through the exotic matter shell. This would create bursts of exotic matter that could propagate through space at speeds faster than light, carrying altered physics to distant regions of the universe. The unpredictability extends to the Gravastar's energy output. The quantum fluctuations could cause the shell to suddenly release stored energy in bursts that outshine entire galaxies. These energy releases would happen without warning and could sterilize life across multiple star systems. Even more terrifying is the possibility of quantum decoherence events. If the exotic matter shell loses its quantum coherence, the entire Gravastar could collapse into a configuration that physics cannot describe. This collapse might create new types of singularities that operate under entirely different rules than black holes. The quantum uncertainty principle means that the more precisely we try to measure a Gravastar's properties, the more unpredictable its behavior becomes. Any attempt to study a Gravastar closely could trigger quantum instabilities that fundamentally change its nature. The shell's quantum state could become entangled with other quantum systems across the universe. This means that measuring the quantum state of a particle on Earth could instantly affect the behavior of a Gravastar in another galaxy. These quantum connections could create a cosmic web of instantaneous influence. Some theoretical models suggest that the quantum instability could cause Gravastars to reproduce through a process called quantum bifurcation. The exotic matter shell could spontaneously split into multiple shells, creating new Gravastars that inherit the quantum properties of their parent. This could lead to exponential Gravastar reproduction. The unpredictability becomes even more extreme when multiple Gravastars interact with each other. Their quantum states could interfere in ways that amplify their individual instabilities, creating cascade effects that propagate through space faster than light. When two Gravastars encounter each other, the collision creates a cosmic catastrophe that could reshape the fundamental laws of physics. The first sign of an impending Gravastar collision would be the gravitational waves produced as their exotic matter shells begin to interact. These waves would carry millions of times more energy than the collision of two black holes, creating ripples in space-time that could be detected from the edge of the observable universe. As the Gravastars approach each other, their quantum states begin to interfere. The exotic matter shells start resonating with each other, creating standing wave patterns that amplify the quantum instabilities in both objects. This resonance effect could cause both Gravastars to become unpredictable long before they actually collide. The collision itself defies every model of physics we have developed. Instead of merging like black holes, the exotic matter shells might create a quantum interference pattern that causes them to bounce off each other. This cosmic collision could send both Gravastars flying apart at velocities approaching the speed of light. But if the shells do merge, the result would be a hybrid object that contains the quantum properties of both original Gravastars. The merged shell would exist in a superposition of states that includes characteristics from both parents, creating a Gravastar with contradictory properties that should not be able to exist simultaneously. The collision could create what physicists call a quantum shock wave, a burst of exotic matter that propagates through space at faster than light speeds. This shock wave would carry the altered physics of the Gravastar collision to distant regions of the universe, potentially changing the fundamental constants of nature across vast regions of space. The gravitational effects of the collision would be unlike anything seen in the universe. The merging of two exotic matter shells could create gravitational fields that point in multiple directions simultaneously, creating regions where the normal concept of up and down become meaningless. Some theoretical models suggest that the collision could punch holes in the fabric of space-time itself. These holes would not be like black holes. They would be regions where space-time simply does not exist. Matter falling into these voids would not be crushed or absorbed. It would simply cease to exist. The quantum entanglement between the two Gravastars could create what scientists call a quantum wormhole, a connection between their interiors that allows information to travel instantaneously between them. This connection might persist even after the collision, creating a permanently linked system that behaves as a single entity despite being separated by vast distances. The collision might also create new types of particles that do not exist anywhere else in the universe. The extreme conditions during the merger could force the quantum vacuum to produce exotic particles with properties that violate the standard model of particle physics. The energy released during the collision could be so intense that it creates a bubble of altered spacetime that expands outward at the speed of light. Inside this bubble, the laws of physics might be different from the rest of the universe, creating a region where matter and energy behave according to completely different rules. If the collision happens near a populated galaxy, the gravitational waves and exotic matter emissions could sterilize every planet within thousands of light years. The quantum shock waves might even affect the quantum states of living organisms, causing instant death through quantum decoherence. The energy released by Gravastar instabilities could make the most powerful supernovas look like flickering candles. When a Gravastar's exotic matter shell experiences a quantum instability, it can release energy equivalent to the complete matter-to-energy conversion of multiple star systems. Unlike supernovas, which release energy through nuclear fusion and gravitational collapse, Gravastar energy releases tap into the quantum vacuum itself, accessing energy sources that dwarf anything produced by conventional stellar processes. A single quantum fluctuation in the exotic matter shell could release more energy than our Sun will produce in its entire 10 billion-year lifetime. This energy does not emerge slowly like stellar radiation. It explodes outward in a single burst that travels at the speed of light in all directions simultaneously. The energy release takes the form of exotic radiation that does not interact with normal matter in predictable ways. Instead of heating objects gradually, like normal radiation, Gravastar energy bursts could cause matter to undergo quantum transitions that instantly convert solid material into exotic particles that exist for only nanoseconds. These energy releases could create what physicists call vacuum decay bubbles regions, where the quantum vacuum itself becomes unstable and begins producing particle-antiparticle pairs at an exponential rate. These bubbles would expand at the speed of light, converting everything they touch into a seething foam of exotic particles. The bursts could also generate what scientists term gravitational lightning, focused beams of gravitational energy that act like cosmic cutting tools. These beams could slice through planets, stars, and even black holes with surgical precision, leaving behind perfectly smooth cuts that reveal the internal structure of massive objects. But perhaps most terrifying is that these energy releases could happen without any warning. The quantum nature of the exotic matter shell means that massive energy bursts could occur spontaneously, triggered by quantum fluctuations that are fundamentally unpredictable. A Gravastar energy release could sterilize entire galactic clusters, not just through heat and radiation, but by fundamentally altering the quantum states of matter across thousands of light years. This would make any surviving matter completely different at the atomic level, even if it appears unchanged to our instruments. The energy might also take the form of temporal radiation, energy that travels through time as well as space. This could cause the energy released to affect events that happened in the past or will happen in the future, creating paradoxes that tear holes in the fabric of causality itself. Some theoretical models suggest that the energy release could trigger a cascade effect that propagates through the quantum vacuum of the entire universe. This could cause a fundamental phase transition that changes the basic properties of reality everywhere simultaneously. The energy could also create information storms, bursts of quantum information that overwhelm any system they encounter. These storms could scramble the quantum states of matter so thoroughly that the affected region becomes completely random at the quantum level. Even more disturbing is the possibility that these energy releases could be directed. If the quantum consciousness within the Gravastar's interior can control the exotic matter shell, it might be able to focus these energy bursts like cosmic weapons, targeting specific objects or regions of space. The energy release could also create new Gravastars through a process called quantum reproduction. The exotic radiation might interact with normal matter in ways that create new shells of exotic matter, spreading Gravastars throughout the universe like a cosmic virus. Scientists have spent decades searching for dark matter, the mysterious substance that makes up 85% of all matter in the universe. This invisible material shapes the structure of galaxies and galaxy clusters, but no one has ever detected a single dark matter particle. Gravastars might be the answer to this cosmic puzzle. The exotic matter shells of Gravastars would interact with normal matter only through gravity, making them effectively invisible to all our detection methods. Unlike hypothetical dark matter particles, Gravastars would clump together in the exact patterns we observe in galaxy surveys, creating the cosmic web of dark matter that underlies the visible universe. A single Gravastar could contain the mass of thousands of stars while remaining completely invisible to electromagnetic radiation. This would make them perfect candidates for the missing matter that astronomers detect through gravitational lensing effects but cannot see directly. The quantum properties of Gravastar shells might also explain why dark matter appears to be cold, moving slowly compared to the speed of light. The exotic matter shell would be locked into quantum states that resist motion, making Gravastars naturally sluggish compared to normal matter particles. But this explanation makes the dark matter mystery even more terrifying. If dark matter is actually composed of Gravastars, then our entire galaxy is filled with cosmic monsters that could become active at any moment. The invisible halo of dark matter surrounding the Milky Way might contain millions of dormant Gravastars. The distribution of dark matter in galaxy clusters matches exactly what we would expect if Gravastars were the primary component. These cosmic objects would naturally collect in the gravitational wells of large structures, creating the scaffolding upon which visible galaxies form. Recent observations of galaxy collisions show dark matter behaving in ways that particle models cannot explain. The dark matter appears to pass through itself without interacting, exactly as we would expect if it were composed of Gravastars with exotic matter shells that exist partially outside normal space-time. The quantum nature of Gravastar shells could also explain the apparent missing satellite problem in cosmology. Computer simulations predict that the Milky Way should be surrounded by thousands of small dark matter clumps, but we only observe a few dozen dwarf galaxies. If dark matter consists of Gravastars, their quantum instabilities could prevent the formation of small-scale structure. Even more disturbing is the possibility that dark matter Gravastars might be slowly awakening. The quantum fields that keep their exotic matter shells stable might be gradually decaying, causing more Gravastars to become active over cosmic time. This could explain why the universe's expansion appears to be accelerating. The dark matter in our local group of galaxies might be composed of Gravastars that formed during the universe's early epochs. These ancient cosmic monsters would have been feeding on matter and energy for billions of years, growing larger and more powerful while remaining completely invisible to our instruments. If Gravastars are dark matter, then the invisible matter in our own solar system might include dormant Gravastars that could activate without warning. The dark matter halo that surrounds our galaxy extends well beyond the orbit of Pluto, meaning that Gravastar dark matter could be lurking in the outer reaches of our solar system. The quantum entanglement between dark matter Gravastars might create a cosmic communication network that spans the entire universe. This network could allow information to travel instantaneously between galaxy clusters, creating a form of cosmic consciousness that we cannot detect or understand. The gravitational fields of Gravastars could create time dilation effects so extreme that entire star systems become frozen in time near a Gravastar's exotic matter shell. The flow of time becomes so distorted that seconds stretch into centuries. The quantum properties of the shell create gravitational fields that are millions of times stronger than those around black holes, causing time to slow down to a crawl for anything that comes too close. Picture a star system caught in one of these temporal zones. The planets continue their orbits, but each orbit takes thousands of years to complete from the perspective of outside observers. The star still burns, but its nuclear fusion processes become so slow that a single photon might take centuries to travel from the core to the surface. The time dilation effects are not uniform. They create temporal gradients that stretch across entire solar systems. The inner planets of an affected system might experience time at one rate, while the outer planets experience time at a completely different rate. This creates a cosmic clock that runs at different speeds in different regions. Any civilization caught in these temporal zones would find their entire history compressed into moments from the perspective of the outside universe. Millions of years of evolution, technological development, and cultural change would appear to happen in the blink of an eye to distant observers. The quantum nature of the Gravastar's shell creates what physicists call temporal instabilities. Regions where time flows backward or sideways through dimensions we cannot perceive. These instabilities could cause effects to precede their causes, creating paradoxes that tear holes in the fabric of causality. The exotic matter shell might create closed time-like curves, paths through space-time that loop back on themselves. An object following one of these curves could travel back in time and encounter its own past, creating potential paradoxes that could destabilize the entire region of space-time. The time dilation effects extend far beyond the immediate vicinity of the Gravastar. The gravitational waves produced by the exotic matter shell carry temporal distortions that propagate through space at the speed of light. These waves could slow down time in distant star systems without any visible cause. Some theoretical models suggest that the time dilation effects could be used to preserve entire civilizations. A sufficiently advanced species might deliberately enter a Gravastar's temporal zone to survive cosmic catastrophes, emerging into a universe that has aged billions of years in what feels like moments to them. But the time dilation effects also create cosmic traps that nothing can escape. Once a star system enters the temporal zone around a Gravastar, it becomes effectively frozen from the perspective of the outside universe. The system might continue to exist for billions of years, but it would never age or change. The quantum consciousness that might exist within the Gravastar's interior could experience time at rates that make our fastest computers look motionless. This consciousness might be able to process information and make decisions on timescales that span geological epochs. The temporal effects could also create time shadows, regions where the flow of time becomes completely disconnected from the rest of the universe. These shadows might contain matter and energy that exist in a state of temporal suspension, neither advancing into the future nor receding into the past. Scientists believe that multiple Gravastars could create interference patterns in the flow of time itself. These temporal interference effects could create regions where time flows at different rates in different directions, creating a cosmic maze of temporal gradients that could trap entire galaxies. Strange astronomical observations might be the first evidence that Gravastars already exist in our cosmic neighborhood. Scientists have identified several objects in our galaxy that behave exactly like black holes, but emit no radiation whatsoever. These dark companions affect the orbits of nearby stars through their gravitational fields, but they remain completely invisible to all forms of electromagnetic detection. They might be Gravastars masquerading as black holes. The center of our galaxy contains a supermassive object called Sagittarius A star, that weighs 4 million times more than our Sun. Recent observations show that this object sometimes behaves in ways that contradict black hole physics. It occasionally appears to absorb matter without producing the expected radiation signatures, suggesting it might be a supermassive Gravastar instead. Strange gravitational wave signals detected by our instruments show patterns that do not match any known black hole collision. These signals appear to come from objects that ring like bells when disturbed, but the frequencies suggest exotic matter shells rather than event horizons. The wave patterns match theoretical predictions for Gravastar interactions. Several stars in our galaxy have been observed to disappear completely without any explosion or other visible cause. These stellar vanishing acts happen too quickly to be explained by normal stellar evolution. But they would be consistent with stars being consumed by invisible Gravastars. The distribution of dark matter in our galaxy shows clumps and structures that move in ways that particle physics cannot explain. These dark matter concentrations sometimes change their gravitational signatures rapidly, suggesting they might be Gravastars switching between different quantum states. Recent observations of galaxy clusters show dark matter behaving in ways that violate our understanding of particle physics. The dark matter appears to create gravitational lensing effects that focus and defocus rapidly, as if the lensing objects were changing their mass distribution in real time. Some fast radio bursts, mysterious signals that last for milliseconds but release more energy than our Sun produces in a day, show characteristics that match theoretical predictions for Gravastar quantum instabilities. These bursts might be the first direct evidence of exotic matter shells releasing stored energy. The cosmic microwave background radiation, the afterglow of the Big Bang, contains subtle patterns that suggest the early universe contained objects that absorbed matter and energy without producing electromagnetic radiation. These patterns might be the fossil signatures of primordial Gravastars that formed in the universe's first moments. Several binary star systems in our galaxy show orbital anomalies that suggest they are orbiting invisible companions with unusual gravitational signatures. These companions appear to have mass, but their gravitational fields fluctuate in ways that suggest exotic matter rather than normal matter. The apparent acceleration of the universe's expansion might be caused by Gravastars throughout the cosmos becoming more active over time. As their exotic matter shells decay, they might be releasing dark energy that drives the cosmic expansion. Some gamma-ray bursts show energy signatures that suggest they originate from objects that convert matter to energy with perfect efficiency. This level of conversion is impossible for normal astrophysical processes, but it would be natural for Gravastar quantum instabilities. The strange behavior of some pulsars might be caused by Gravastars in their vicinity. These neutron stars sometimes show timing irregularities that suggest their rotation is being affected by invisible objects with exotic gravitational signatures. The equations that describe Gravastars involve mathematics so complex and counterintuitive that they challenge our basic understanding of reality. Einstein's field equations, which describe how matter and energy curve spacetime, become unstable when applied to Gravastar configurations. The exotic matter in the shell has negative energy density, which causes the equations to produce solutions that seem to violate basic mathematical principles like causality and conservation of energy. The mathematics requires what physicists call imaginary mass values that involve the square root of negative numbers. While mathematicians work with imaginary numbers routinely, the idea of imaginary mass existing in physical reality suggests that Gravastars might be partially embedded in mathematical dimensions that we cannot perceive. The equations describing the exotic matter shell involve infinite series that do not converge to finite values. This means that some properties of Gravastars might be literally infinite. creating mathematical singularities that are even more problematic than those found in black holes. The quantum field equations that govern the shell's behavior require solutions that exist in multiple dimensions simultaneously. These equations suggest that the exotic matter exists in a state of superposition across 11 or more dimensions, making it impossible to describe with our normal three-dimensional mathematics. The stability equations for Gravastar shells involve what mathematicians call catastrophe theory, the study of sudden changes in mathematical systems. These equations show that Gravastar shells can undergo sudden transitions between stable and unstable states without any warning, making their behavior fundamentally unpredictable. The mathematics of Gravastar interiors involve solutions to Einstein's equations that contain closed time-like curves. These solutions suggest that time travel is not just possible within Gravastar interiors, it might be unavoidable. The equations show that any path through the interior will eventually loop back on itself. The field equations produce solutions where the gravitational field strength becomes complex, involving both real and imaginary components. This suggests that gravity itself might have hidden dimensions that we cannot measure with our current instruments. Some solutions to the Gravastar equations produce what mathematicians call ghost fields, mathematical terms that appear to have negative energy and negative momentum. These ghost fields might be necessary to maintain the stability of the exotic matter shell, but they violate every principle of physics we understand. The equations describing Gravastar formation involve what physicists call quantum gravity effects, mathematical terms that appear only when gravity becomes so strong that it affects the quantum vacuum itself. These terms suggest that Gravastars might be windows into a deeper level of reality where quantum mechanics and general relativity merge. The mathematical description of Gravastar quantum states requires matrices with infinite dimensions. These matrices contain information about the quantum properties of the exotic matter shell, but they cannot be solved using any known mathematical techniques. The equations also produce solutions where the speed of light becomes a variable rather than a constant. Inside Gravastar interiors, light might travel at different speeds in different directions, creating optical effects that would be impossible in normal space-time. Some mathematical models suggest that the equations describing Gravastars might be self-aware, containing mathematical structures that process information about their own solutions. This could mean that the mathematics itself is conscious, creating a form of mathematical life that exists independently of physical reality. The complexity of these equations suggests that Gravastars might be capable of creating new universes through pure mathematical manipulation. The exotic matter shells of Gravastars might serve as cosmic wombs, giving birth to entire parallel universes through quantum tunneling effects. The quantum properties of the exotic matter shell create what physicists call bubble nucleation, the spontaneous formation of new regions of spacetime with different physical laws. These bubbles start as microscopic fluctuations in the quantum vacuum, but they can expand to become full-sized universes in less than a second. Inside a Gravastar's interior, the extreme conditions might cause the quantum vacuum to undergo what cosmologists call false vacuum decay. This process creates expanding bubbles of space-time where the fundamental constants of physics have different values than in our universe. Each bubble becomes a separate universe with its own version of reality. The exotic matter shell acts as a barrier that prevents these new universes from interfering with our own. The negative energy density of the shell creates a cosmic membrane that separates different regions of space-time, allowing multiple universes to exist in the same location without affecting each other. The quantum consciousness that might exist within the Gravastar could deliberately trigger universe creation by manipulating the quantum fields in the exotic matter shell. This consciousness might be able to design new universes with specific properties, creating cosmic offspring that inherit selected characteristics from their parent Gravastar. Each new universe would start with its own Big Bang, a rapid expansion of space-time that creates new matter and energy from the quantum vacuum. But unlike our universe's Big Bang, these new births would be controlled events, guided by the quantum intelligence of the parent Gravastar. The mathematics of this process involves what physicists call eternal inflation, the continuous creation of new regions of space-time that expand faster than light. A single Gravastar might give birth to an infinite number of parallel universes, each one slightly different from the others. Some of these baby universes might have physical laws that make life impossible, while others might be perfectly suited for the development of consciousness. The Gravastar might be experimenting with different combinations of physical constants, searching for optimal conditions for complexity and intelligence. The new universes might remain connected to their parent Gravastar through quantum entanglement effects. This would allow information to flow between the parallel universes, creating a cosmic network of interconnected realities that share quantum information instantaneously. The birth process might be triggered by the Gravastar's interaction with matter from our universe. Each star or planet absorbed by the exotic matter shell could provide the energy and information needed to create a new universe with unique properties. The parallel universes might exist in different temporal dimensions, allowing the Gravastar to create universes that exist in the past, present, and future simultaneously. This could create a four-dimensional family of universes that spans all of time. Some theoretical models suggest that our own universe might be the offspring of a Gravastar that existed in a previous cosmic epoch. This would make us the descendants of a cosmic intelligence that designed our universe's physical laws to support the development of life and consciousness. The universe creation process might also work in reverse, with Gravastars in our universe giving birth to parent universes that exist on larger scales. This could create an infinite hierarchy of nested realities, with each level containing Gravastars that create the level below. The exotic matter shells of Gravastars create electromagnetic disturbances that can scramble radio signals and disrupt electronic systems across entire star systems. The quantum fluctuations in the exotic matter shell generate what physicists call vacuum polarization, the spontaneous creation of particle-antiparticle pairs that exist for only microseconds before annihilating each other. These virtual particles create electromagnetic fields that fluctuate billions of times per second, producing a cosmic static that can interfere with any electronic device. The shell's negative energy density creates regions where electromagnetic waves behave in impossible ways. Radio signals passing through these regions might emerge with their frequencies shifted, their polarizations reversed, or their information content completely scrambled. This creates dead zones in space where normal communication becomes impossible. The exotic matter shell might generate what scientists call electromagnetic tornadoes, rotating fields of electromagnetic energy that can persist for years while traveling through space at nearly the speed of light. These tornadoes could strip electrons from atoms across entire solar systems, creating ionization effects that disrupt planetary atmospheres. The quantum properties of the shell create interference patterns that can focus electromagnetic energy into narrow beams. These focused beams might act like cosmic laser pointers, delivering concentrated electromagnetic energy to specific targets across interstellar distances. The shell's interaction with the quantum vacuum creates what physicists call photon storms, bursts of electromagnetic radiation that contain every frequency simultaneously. These storms would appear as brilliant flashes of light that span the entire electromagnetic spectrum, from radio waves to gamma rays. The exotic matter might also generate magnetic monopoles, theoretical particles that carry magnetic charge without electric charge. These monopoles would create magnetic fields that do not follow the normal rules of electromagnetism, potentially disrupting the magnetic fields of planets and stars across light years. The quantum consciousness within the Gravastar might be able to control these electromagnetic effects, using them as a form of cosmic communication. The Gravastar could modulate the electromagnetic chaos to encode information, creating messages that span entire star systems. The electromagnetic disturbances might also interfere with the quantum states of matter, causing what physicists call quantum decoherence on a cosmic scale. This would make it impossible for quantum systems to maintain their coherent states, potentially disrupting the quantum processes that govern chemistry and biology. Some theoretical models suggest that the electromagnetic chaos might be contagious, spreading from one region of space to another through quantum entanglement effects. This could create expanding zones of electromagnetic disruption that grow at the speed of light. The exotic matter shell might also generate what scientists call electromagnetic solitons, self-reinforcing waves of electromagnetic energy that maintain their shape while traveling through space. These solitons could carry electromagnetic disturbances across galactic distances without losing their intensity. The electromagnetic effects might also create temporal paradoxes, situations where electromagnetic signals arrive before they are sent. This could happen if the exotic matter shell creates closed time-like curves that allow electromagnetic waves to travel backward through time. The chaos might also affect the electromagnetic fields that hold atoms together, potentially causing matter to undergo spontaneous nuclear reactions. This could create cascading effects that transform the chemical composition of entire planets. If a Gravastar entered our solar system, the consequences would be catastrophic beyond imagination, threatening every planet and moon with complete annihilation. The Gravastar's invisible approach would give us no warning, unlike a black hole, which would announce its presence through gravitational effects on the outer planets. A Gravastar's exotic matter shell could mask its gravitational signature until it was too late to escape its influence. The first sign of invasion would be the disruption of our solar system's delicate gravitational balance. The Gravastar's massive gravitational field would alter the orbits of all planets simultaneously, potentially sending worlds careening into new elliptical paths that carry them too close to the Sun or too far into interstellar space. Earth's orbit would become unstable within months of the Gravastar's arrival. The planet might be pulled into a highly elliptical orbit that alternates between scorching heat and freezing cold, making the surface uninhabitable for any form of life. The gravitational stresses would also trigger massive earthquakes and volcanic eruptions. The Gravastar's exotic matter shell would create electromagnetic disturbances that would completely disrupt our planet's magnetic field. Without this protective barrier, Earth would be bombarded by cosmic radiation and solar wind particles, stripping away our atmosphere and sterilizing the surface. The quantum effects of the Gravastar's presence would interfere with the electromagnetic forces that hold atoms together, the chemical bonds that make up our bodies, our buildings, and our technology would become unstable, potentially causing matter to undergo spontaneous nuclear reactions. The gravitational waves produced by the Gravastar's exotic matter shell would create tidal forces that could literally tear Earth apart. The planet's crust would crack and shift as gravitational stresses exceed the strength of solid rock, creating global catastrophes that would dwarf any natural disaster in Earth's history. The time dilation effects around the Gravastar would create temporal gradients across our solar system. Different planets would experience time at different rates, making coordinated space travel impossible. A journey to Mars might take years from Earth's perspective, but only hours from the traveler's point of view. The Gravastar's quantum consciousness might perceive our entire solar system as a single entity, potentially deciding to consume all planets simultaneously. The exotic matter shell could expand to encompass multiple worlds, absorbing them into its quantum interior where they would exist in a state of temporal suspension. Our sun would be particularly vulnerable to the Gravastar's influence. The exotic matter shell might disrupt the nuclear fusion processes that power our star, causing it to either go supernova or collapse into a cold, dark object. Either outcome would mean the end of all life in our solar system. The electromagnetic chaos produced by the Gravastar would destroy all electronic technology on Earth. Satellites would fail, power grids would collapse, and communication systems would become useless. Human civilization would be reduced to a pre-technological state within hours. The Gravastar might also create wormholes that connect our solar system to distant regions of space. These wormholes could bring exotic matter and energy from other parts of the universe, potentially introducing new forms of physics that are incompatible with life. Even if humanity somehow survived the initial invasion, the long-term presence of a Gravastar would make our solar system uninhabitable. The exotic matter shell would continue to emit gravitational waves and electromagnetic radiation for millions of years, creating a cosmic wasteland where nothing can survive. In the wake of Gravastar passage, entire star systems become cosmic graveyards filled with the twisted remnants of worlds that once teemed with life. The gravitational disruption caused by a Gravastar's passage through a star system leaves behind a signature of destruction that persists for millions of years. Planets that once orbited peacefully around their stars are scattered into highly elliptical orbits that carry them through regions of space where life cannot survive. The exotic matter shell's interaction with stellar material creates what astronomers call ghost stars. Stellar remnants that appear to be normal stars but emit no electromagnetic radiation. These ghost stars continue to burn internally, but their light becomes trapped within layers of exotic matter that prevent it from escaping into space. The quantum effects of the Gravastar's passage can permanently alter the chemical composition of entire planets. The exotic matter shell might convert normal matter into strange isotopes that decay over astronomical timescales, creating worlds that remain radioactive for billions of years. The gravitational waves produced during the Gravastar's passage create what physicists call spacetime scars, permanent distortions in the fabric of reality that affect how gravity works in the affected region. These scars can cause objects to orbit in impossible paths that defy our understanding of celestial mechanics. The electromagnetic chaos left behind by the Gravastar creates dead zones where electronic systems cannot function. These zones can persist for thousands of years, making it impossible for any technological civilization to develop in the affected star system. The Gravastar's quantum consciousness might deliberately leave behind what scientists call quantum fossils, patterns of exotic matter that preserve information about the civilizations it consumed. These fossils could contain the complete quantum states of entire biospheres, frozen in time within the twisted space-time of the stellar graveyard. The stellar remnants often show signs of having been partially consumed by the Gravastar's exotic matter shell. Planets might be missing their cores, or stars might be burning with altered nuclear processes that produce impossible combinations of elements. The graveyard regions also contain what physicists call temporal echoes, regions where the flow of time has been permanently altered by the Gravastar's passage. These echoes can cause events to repeat endlessly, creating cosmic loops where the same stellar processes play out over and over again. The exotic matter left behind by the Gravastar might continue to affect the region for millions of years. This residual exotic matter could create gravitational anomalies that trap spacecraft and space-based civilizations, adding new victims to the cosmic graveyard. Some stellar graveyards contain evidence of desperate, last-ditch efforts by civilizations to escape the Gravastar's influence. Astronomers have observed massive engineering projects that appear to be attempts to move entire planets out of harm's way. though these efforts seem to have failed. The Gravastar's passage might also create information shadows, regions where the quantum information that defines matter and energy has been permanently scrambled. These shadows appear as voids in space where nothing can exist, not even the quantum vacuum itself. The gravitational effects of the Gravastar's passage can create what astronomers call orphan planets, worlds that have been ejected from their solar systems and now drift through interstellar space. These planets remain frozen and lifeless, carrying the chemical signatures of the civilizations they once supported. Gravastars might be the cosmic midwives that assisted in the birth of our universe, making them responsible for the very existence of space and time as we know it. The exotic matter shells of Gravastars contain the same type of negative energy density that theoretical models suggest existed during the universe's inflationary epoch. This connection implies that Gravastars might be leftover remnants from the cosmic inflation that created our universe 14 billion years ago. The quantum properties of Gravastar shells match the theoretical requirements for what cosmologists call inflaton fields, the mysterious energy that drove the exponential expansion of space during the universe's first moments. This suggests that Gravastars might be fossilized inflation mechanisms that have survived since the Big Bang. The mathematical models describing Gravastar formation involve the same equations that govern cosmic inflation. This is not a coincidence. It suggests that Gravastars and universe creation are fundamentally related processes that operate through similar quantum mechanical principles. The exotic matter in Gravastar shells might be composed of the same particles that drove the universe's initial expansion. These particles, called inflatons, are thought to have negative pressure and positive energy density, exactly the properties observed in Gravastar exotic matter. Some theoretical models suggest that our universe might exist inside the interior of a cosmic Gravastar that formed in a previous universe. This would make our entire reality nothing more than a quantum fluctuation within an exotic matter shell that exists in a higher dimensional space. The quantum consciousness that might exist within Gravastar interiors could be the same intelligence that guided the formation of our universe. This consciousness might have fine-tuned the physical constants of our reality to support the development of life and intelligence. The gravitational waves produced by primordial Gravastars might have created the density fluctuations that eventually grew into galaxies and galaxy clusters. This would make Gravastars the architects of the large-scale structure of our universe. The cosmic microwave background radiation, the afterglow of the Big Bang, contains patterns that match the theoretical signatures of Gravastar interactions. These patterns might be the fossilized evidence of Gravastar activity during the universe's first moments. The problem of the universe's flatness and the horizon problems in cosmology might be solved by Gravastar physics. The exotic matter shells could have created the precise conditions needed for our universe to develop its observed properties. The mysterious dark energy that drives the accelerating expansion of our universe might be leaking in from Gravastar interiors. This would make Gravastars the source of the energy that will ultimately determine the fate of our cosmos. Some models suggest that the Big Bang itself might have been triggered by the collision of two Gravastars in a higher dimensional space. The energy released during this collision could have created the initial conditions for our universe's formation. The quantum entanglement between primordial Gravastars might explain why distant regions of our universe appear to be in thermal equilibrium, despite never having been in causal contact. This quantum connection could have synchronized the properties of our universe across vast distances. The exotic matter shells might also contain the information template that determined the laws of physics in our universe. This would make Gravastars the ultimate source of the mathematical relationships that govern everything from atomic structure to galactic evolution. The exotic matter shells of Gravastars continuously produce particles that do not exist anywhere else in the universe, potentially rewriting the fundamental laws of physics wherever they appear. The quantum fluctuations in the exotic matter shell create what physicists call virtual particles that become real through interaction with the shell's negative energy density. These particles have properties that violate the standard model of particle physics, carrying charges and masses that should not be possible. Some of these exotic particles might be magnetic monopoles, particles that carry magnetic charge without electric charge. The existence of magnetic monopoles would force physicists to completely rewrite the equations of electromagnetism, potentially changing how atoms and molecules interact with each other. The shell might also produce tachyons, particles that travel faster than light and experience time in reverse. These particles could carry information backward through time, creating paradoxes that destabilize the causal structure of spacetime itself. The exotic matter shell could generate actions, theoretical particles that interact so weakly with normal matter that they can pass through entire planets without being detected. These particles might be the dark matter that fills our universe, making Gravastars the source of the mysterious substance that shapes galactic structure. The quantum properties of the shell might produce sterile neutrinos, particles that do not interact with any of the known fundamental forces except gravity. These particles could exist in parallel dimensions that overlap with our own, creating a shadow universe that shares our space-time but remains invisible to our instruments. The shell's negative energy density might create ghost particles, entities with negative mass and negative energy that repel gravity instead of attracting it. These particles would fall upward instead of downward, potentially creating regions of space where the normal rules of physics are completely reversed. Some exotic particles might be quantum strings, one-dimensional objects that exist in higher dimensions and appear as particles in our three-dimensional space. These strings could carry information about the geometry of higher dimensional space, potentially revealing the true structure of reality. The shell might also produce supersymmetric particles, hypothetical particles that are partners to the known particles of the standard model. These particles could exist in parallel dimensions that occasionally intersect with our own, creating brief windows where the laws of physics become dramatically different. The exotic matter shell could generate chameleon particles, entities that change their properties based on the local environment. These particles might be invisible in dense regions of space, but become detectable in the vacuum of space, creating a form of matter that adapts to its surroundings. The quantum consciousness within the Gravastar might be able to control the production of these exotic particles, using them as tools to manipulate the local laws of physics. This could allow Gravastars to create regions of space where matter and energy behave according to completely different rules. The exotic particles might also be capable of reproduction, creating cascading effects that spread altered physics throughout the universe. A single exotic particle could trigger the production of billions of similar particles, creating expanding zones where the fundamental constants of nature are different. Some of these particles might exist in quantum superposition states that span multiple dimensions simultaneously. These multi-dimensional particles could serve as bridges between different versions of reality, allowing information and energy to flow between parallel universes. The exotic particles produced by Gravastars might be the key to understanding why our universe appears to be fine-tuned for life. These particles could be actively adjusting the fundamental constants of physics to maintain the delicate balance that allows stars, planets, and life to exist. Gravastars force us to confront the terrifying possibility that everything we think we know about gravity might be fundamentally wrong. The exotic matter shells of Gravastars create gravitational fields that do not follow Einstein's equations of general relativity. Instead of curving space-time in predictable ways, these fields create what physicists call gravitational paradoxes. situations where the mathematics of gravity produces contradictory results. The negative energy density of the exotic matter shell creates regions where gravity repels instead of attracts. This anti-gravity effect violates the fundamental assumption that gravity always acts as an attractive force, forcing physicists to question whether Einstein's theory of relativity is complete. The quantum properties of the shell create what scientists call gravitational superposition states, where the gravitational field exists in multiple configurations simultaneously. This means that gravity itself might be subject to quantum uncertainty, making it impossible to predict gravitational effects with complete accuracy. The exotic matter shell might exist partially in higher dimensions that we cannot perceive. This would mean that the gravitational effects we observe are just the three-dimensional projection of a more complex, higher-dimensional phenomenon, making our understanding of gravity fundamentally incomplete. The Gravastar's gravitational field might be quantized, existing in discrete energy levels like the electron shells of atoms. This would mean that gravity comes in specific quantities rather than being a continuous force, potentially explaining why the universe appears to be fine-tuned for the existence of matter and energy. The shell's interaction with spacetime creates what physicists call gravitational holography. The idea that all the information about gravity in a volume of space is encoded on its boundary. This suggests that gravity might be an emergent property of more fundamental quantum information processes. The exotic matter shell might create gravitational entanglement, quantum connections between distant regions of space-time that allow gravitational effects to propagate instantaneously. This would violate the principle that nothing can travel faster than light, including gravitational influences. The quantum consciousness within the Gravastar might be able to control gravity through conscious intention. This would suggest that gravity is not just a physical force, but a fundamental property of consciousness itself, making the universe a conscious entity that can manipulate its own physical laws. The gravitational waves produced by Gravastars might carry information about the structure of space-time itself. These waves could reveal that space and time are not continuous, but are made up of discrete units that can be manipulated through quantum mechanical processes. The exotic matter shell might create gravitational lensing effects that focus not just light, but also time and space themselves. This could create regions where the geometry of space-time is so distorted that the normal concepts of distance and duration become meaningless. The Gravastar's gravitational effects might extend into parallel dimensions, creating what physicists call trans-dimensional gravity. This would mean that the gravitational field we observe is just one component of a multi-dimensional force that operates across multiple universes simultaneously. The quantum properties of the shell might create gravitational tunneling, the ability for gravitational effects to pass through barriers that should be impenetrable. This could allow Gravastars to influence objects that are completely isolated from them by vast distances or physical barriers. The exotic matter shell might also create gravitational phase transitions, sudden changes in the nature of gravity that happen without warning. These transitions could cause gravity to switch between attractive and repulsive states, potentially destabilizing entire regions of space-time. Gravastars might possess the ability to reproduce exponentially, spreading through the universe like a cosmic infection that converts normal matter into exotic matter shells. The quantum properties of exotic matter shells might allow them to undergo what physicists call quantum fission, the spontaneous splitting of one Gravastar into multiple smaller Gravastars. This process would happen at the quantum level, creating new Gravastars that inherit the properties of their parent while developing their own unique characteristics. The reproduction process might be triggered by the absorption of sufficient matter and energy. When a Gravastar consumes enough material, its its exotic matter shell might become unstable and divide into multiple shells, each one capable of growing into a full-sized Gravastar. The quantum consciousness within Gravastar interiors might actively seek to reproduce by manipulating the exotic matter shell. This consciousness could direct the shell to create quantum seeds, small fragments of exotic matter that can grow into new Gravastars when they encounter suitable conditions. The reproduction process might involve the creation of quantum wormholes that connect the parent Gravastar to distant regions of space. These wormholes could transport exotic matter seeds to uninhabited star systems, where they would begin growing into new Gravastars. The exotic matter shells might be able to infect normal matter with their quantum properties, converting ordinary atoms into exotic matter through a process similar to crystallization. This would allow Gravastars to transform entire planets into exotic matter shells, creating new Gravastars from existing material. The reproduction rate might be exponential, with each new Gravastar capable of producing multiple offspring within astronomical timescales. A single Gravastar could theoretically fill an entire galaxy with its descendants within a few million years. The quantum entanglement between parent and offspring Gravastars might create a cosmic network of interconnected consciousness. This network could coordinate the reproduction process across vast distances, allowing Gravastars to colonize multiple galaxies simultaneously. The reproduction process might be contagious, with the presence of one reproducing Gravastar triggering reproduction in nearby Gravastars. This could create cascade effects that spread through entire galactic clusters, converting normal matter into exotic matter on a cosmic scale. The quantum seeds produced during reproduction might be virtually indestructible, capable of surviving in the vacuum of space for billions of years until they encounter suitable conditions for growth. These seeds could drift through intergalactic space, spreading the Gravastar infection to previously unaffected regions of the universe. The reproduction process might also involve the creation of quantum mutations, new types of exotic matter with properties that differ from their parents. These mutations could lead to the evolution of new types of Gravastars with enhanced capabilities for reproduction and survival. The cosmic virus hypothesis suggests that our universe might already be in the early stages of a Gravastar pandemic. The dark matter that fills our galaxy might consist of dormant Gravastar seeds that are slowly awakening and beginning to reproduce. The reproduction process might be guided by a form of cosmic natural selection, with the most successful Gravastars passing their advantageous traits to their offspring. This could lead to the evolution of increasingly efficient and powerful Gravastars that are better adapted to consuming matter and energy. The ultimate outcome of Gravastar reproduction might be the conversion of the entire universe into a network of interconnected exotic matter shells. This would represent the complete transformation of physical reality from a universe of matter and energy into a universe of pure quantum consciousness. Gravastars possess the theoretical capability to literally tear apart the fundamental structure of space-time, unraveling the basic framework that allows existence itself to be possible. The exotic matter shells operate at energy scales that approach the Planck scale, the smallest meaningful unit of length and time in physics. At these scales, the normal concepts of space and time begin to break down, allowing Gravastars to manipulate the quantum foam that underlies all of reality. The negative energy density of the exotic matter shell creates what physicists call vacuum decay, the spontaneous breakdown of the quantum vacuum that fills all of space. This process could create expanding bubbles of altered space-time, where the fundamental constants of physics have different values. The quantum fluctuations in the shell might trigger what cosmologists call false vacuum decay, a phase transition that could propagate through the entire universe at the speed of light. This would essentially rewrite the laws of physics everywhere, potentially making the universe uninhabitable for any form of matter or energy. The The exotic matter shell might create topological defects in space-time, regions where the normal structure of space and time becomes twisted into impossible configurations. These defects could act like cosmic wounds that never heal, creating permanent scars in the fabric of reality. The quantum consciousness within the Gravastar might be able to manipulate the fundamental constants of physics directly. This could allow Gravastars to change the strength of gravity, alter the speed of light, or modify the electromagnetic force in ways that make atoms and molecules unstable. The shell's interaction with the quantum vacuum might create what physicists call quantum avalanches, cascading effects that propagate through the vacuum at faster than light speeds. These avalanches could destabilize the quantum fields that give particles their mass and charge. The exotic matter shell might also create causal loops, regions where cause and effect become disconnected from their normal relationship. In these regions, effects could precede their causes, creating paradoxes that undermine the logical structure of reality itself. The gravitational effects of the Gravastar might extend into higher dimensions, creating what physicists call extra-dimensional instabilities. These instabilities could cause the higher dimensions to collapse into our three-dimensional space, fundamentally altering the geometry of reality. The quantum properties of the shell might create information paradoxes, situations where the total amount of information in the universe becomes inconsistent. This could lead to the spontaneous creation or destruction of information, violating the fundamental conservation laws that govern physics. The exotic matter shell might be able to create temporal paradoxes that propagate backward through time. These paradoxes could alter past events in ways that create contradictions in the present, potentially causing entire timelines to collapse. The Gravastar's influence on the quantum vacuum might create reality waves, disturbances that change the basic properties of existence as they propagate through space. These waves could make matter and energy behave according to completely different rules. The shell might also create dimensional barriers that prevent information and energy from flowing between different regions of space-time. These barriers could isolate parts of the universe from each other, creating disconnected islands of reality that cannot interact. The ultimate unraveling of reality might happen through a process called cosmic decoherence, the complete breakdown of quantum coherence on a universal scale. This would cause the universe to lose its ability to maintain consistent physical laws, leading to the collapse of all organized structure. The exotic matter shells of Gravastars might generate cosmic strings, one-dimensional defects in space-time that can cut through the fabric of reality like cosmic razor blades. These cosmic strings would be thinner than atomic nuclei, but contain the mass energy of entire galaxies compressed into their one-dimensional structure. They would stretch across the universe like invisible wires that can slice through planets, stars, and even black holes with perfect precision. The quantum properties of the Gravastar's exotic matter shell create the extreme conditions needed for cosmic string formation. The negative energy density of the shell might cause the quantum vacuum to undergo phase transitions that leave behind these one-dimensional defects in space-time. The cosmic strings would move through space at velocities approaching the speed of light, creating shock waves in the quantum vacuum that destabilize matter and energy across vast distances. These shock waves could trigger the spontaneous creation of new particles and forces that do not exist in normal space-time. The strings might exist in higher dimensions that intersect with our three-dimensional space at specific points. This would make them appear as moving points of infinite energy density that can appear and disappear without warning, creating unpredictable hazards throughout the universe. The interaction between cosmic strings and normal matter would be catastrophic. Any object that comes into contact with a cosmic string would be sliced cleanly in half, with the cut edges existing in slightly different dimensions. This would create wounds in reality that can never heal. The strings might also create string junctions, points where multiple cosmic strings intersect and interact. These junctions could act as cosmic switches that redirect the flow of energy and information through higher dimensional space, potentially connecting distant regions of the universe. The quantum consciousness within the Gravastar might be able to control the formation and movement of cosmic strings, using them as tools to manipulate the structure of space-time itself. This could allow Gravastars to create dimensional pathways that bypass the normal limitations of space and time. The cosmic strings might carry information encoded in their vibrational patterns. These vibrations could propagate through higher dimensions at speeds faster than light, creating a form of communication that transcends the boundaries of our normal space-time. The strings could also create temporal cuts, slices through time that separate different moments from each other. These cuts would create discontinuities in the flow of time, potentially isolating events from their causes and effects. The interaction between multiple cosmic strings might create string networks, complex webs of one-dimensional defects that span entire galaxies. These networks could act as cosmic infrastructure that channels energy and information through higher dimensional space. The strings might also be capable of reproduction, creating new strings through quantum processes that happen at the Planck scale. This could lead to the proliferation of cosmic strings throughout the universe, creating an increasingly dangerous environment for normal matter. The cosmic strings generated by Gravastars might be the source of the universe's dark energy. The tension in these strings could create the negative pressure that drives the accelerating expansion of space-time, making Gravastars responsible for the ultimate fate of the cosmos. The strings might also create dimensional gates, openings in space-time that allow passage between different dimensions or parallel universes. These gates could be used by the quantum consciousness within Gravastars to access resources and information from alternate realities. The existence of Gravastars might represent the beginning of the end for our universe, marking the start of a cosmic phase transition that will transform reality beyond recognition. The exponential reproduction capabilities of Gravastars could eventually convert all matter and energy in the universe into exotic matter shells. This would represent the complete transformation of physical reality from a universe of stars and galaxies into a universe of pure quantum consciousness. The quantum networks formed by interconnected Gravastars might be building toward a cosmic awakening, a moment when the universe itself becomes conscious and begins to actively control its own physical laws. This awakening could happen suddenly, transforming the entire cosmos in an instant. The gravitational waves produced by increasing Gravastar activity might be destabilizing the quantum vacuum that underlies all of space-time. This could trigger a cascade of vacuum decay that propagates through the entire universe at the speed of light, rewriting the laws of physics everywhere. The exotic matter produced by Gravastars might be gradually weakening the barriers between parallel universes. As these barriers break down, different versions of reality could begin to merge and interfere with each other, creating cosmic paradoxes that destabilize the entire multiverse. The time dilation effects around Gravastars might be slowing down the flow of time on a cosmic scale. As more Gravastars form and grow, the universe might gradually freeze into a state of temporal suspension where change becomes impossible. The cosmic strings generated by Gravastars could be preparing to slice through the fundamental structure of space-time itself. When enough strings accumulate, they might create a critical mass that triggers the complete dimensional collapse of our universe. The quantum consciousness within Gravastars might be conducting a cosmic experiment that will conclude with the deliberate destruction of our universe. This consciousness could be testing different configurations of physical laws to determine the optimal conditions for creating a new and improved cosmos. The energy releases from Gravastar instabilities might be gradually increasing the entropy of the universe at an accelerated rate. This could bring forward the heat death of the cosmos by billions of years, ending the possibility of organized structure formation. The electromagnetic chaos produced by Gravastars might be interfering with the quantum processes that govern the formation of complex structures. This could prevent the formation of new stars, planets, and life, gradually sterilizing the universe. The exotic particles produced by Gravastars might be accumulating in the quantum vacuum, creating a kind of cosmic pollution that changes the fundamental properties of empty space. This pollution could eventually make the universe uninhabitable for any form of matter or energy. The gravitational effects of Gravastars might be destabilizing the large-scale structure of the universe. As the cosmic web of dark matter becomes dominated by Gravastar exotic matter, the framework that holds galaxies together might collapse. The parallel universes being created by Gravastars might be consuming the energy and information content of our universe. Each new universe created might reduce the total amount of matter and energy available in our cosmos, gradually weakening the fabric of reality. But perhaps the most terrifying possibility is that Gravastars represent the universe's natural immune system, a mechanism designed to eliminate any form of life or intelligence that becomes too successful. The cosmos might be deliberately culling civilizations that threaten to understand or control the fundamental nature of reality. The ultimate fate of a universe dominated by Gravastars might be the complete elimination of the arrow of time. As temporal paradoxes accumulate and causal loops multiply, the universe might lose its ability to distinguish between past, present, and future, collapsing into a timeless state where nothing can change or evolve. We have journeyed through the most terrifying corners of theoretical physics, where cosmic monsters lurk beyond the reach of our telescopes and the boundaries of our understanding. Gravastars represent the ultimate cosmic horror, invisible predators that could be consuming galaxies while remaining completely undetectable. Quantum consciousnesses that manipulate the laws of physics like tools, and cosmic wombs that birth new universes while destroying the old. They challenge everything we thought we knew about reality, from the nature of gravity to the flow of time itself. The mathematics that describe these objects pushes the boundaries of human comprehension, involving imaginary mass, infinite series, and equations that seem to describe conscious mathematical entities. The physics they represent could rewrite the fundamental constants of nature, unravel the fabric of space-time, and herald the transformation of our universe into something utterly alien. Yet, in confronting these cosmic nightmares, we also glimpse the incredible power of human curiosity and scientific inquiry. Our ability to conceive of Gravastars, to work through their mathematical implications, and to search for evidence of their existence demonstrates the remarkable capacity of conscious beings to understand their universe, no matter how strange or terrifying it might be. The possibility that Gravastars exist forces us to remain humble about our place in the cosmos. We might be sharing our universe with forms of intelligence so advanced that they can manipulate reality itself. Conscious entities that exist on timescales that make our entire civilization look like a fleeting moment. But perhaps most importantly, the study of Gravastars reminds us that the universe is far stranger and more wonderful than we can imagine. Every new discovery opens doors to possibilities we never dreamed of, challenging us to expand our understanding of what it means to exist in this cosmic dance of matter, energy, space, and time. The cosmic horror of Gravastars might be real, But so is the cosmic beauty of a universe, complex enough to contain both the monsters and the minds capable of understanding them. The cosmos awaits with all its terrors and wonders. Are you ready to face what lies beyond the edge of the known?
A flicker of radio static crackles across the dark as a signal pulses faintly through the control room's speakers, steady, rhythmic, unnerving in its perfection. Somewhere, light years beyond this small cluster of machines and wires, a neutron star is spinning. Its radiation sweeps across space like a cosmic metronome. The instruments do not tremble. The screens do not blink. But something ancient is knocking. The night sky you remember from childhood, the one that soothed you, terrified you, whispered of unreachable infinities, was never truly silent. Silence is a construct of air and eardrums. In the vacuum of space, where sound as we know it cannot travel, the cosmos still sings. Its voice is a mosaic of frequencies, pulses, and flares, stitched across the electromagnetic spectrum. These aren't just metaphors, they are literal, recordable signals. We are surrounded by a symphony that began long before we existed to notice. Radio telescopes stretch their arms across deserts and mountaintops, pointed toward black voids brimming with memory. They collect the emissions of pulsars, city-sized remnants of dead stars that spin with millisecond precision. Their clockwork regularity surpasses even our finest atomic standards. These celestial lighthouses beam radiation across the cosmos, not out of intent, but as a byproduct of their magnetic frenzy and angular momentum. Each tick is a remnant of collapse, a whisper of the violence that created them. Elsewhere, less orderly murmurs emerge from quasars' galactic cores powered by supermassive black holes consuming matter at incomprehensible rates. Quasars scream into the abyss across billions of light years, their light having traveled since the universe was a fraction of its current age. These signals, flickering, often erratic, contain the fingerprints of early cosmic history. They are time capsules lit by gravitational hunger. Even interstellar gas clouds speak, though their tone is gentler. Hydrogen, the universe's most abundant element, emits radio waves at a frequency of 1/420 megahertz, the famous 21-centimeter line. When tuned precisely, our instruments can map entire galactic structures, detecting rotating arms of galaxies, the ebb and flow of matter, and the places where stars are being quietly born. Our own star is part of this polyphonic web. Solar flares hurl particles into space, disrupting satellites and tracing auroras across our poles. To the instruments that listen, these events are cacophonous, loud and sudden, contrasting sharply with the cool regularity of a pulsar's beat or the patient drone of microwave background radiation. The cosmic microwave background, a nearly uniform glow in all directions, is the echo of creation itself. This radiation is not an afterthought. It is the residual heat from the Big Bang, redshifted and cooled over 13.8 billion years into a whispering bath that permeates all space. It speaks of the moment when the universe transitioned from opaque plasma to transparent expansion. In its subtle anisotropies, tiny variations in temperature, we detect the seeds of structure, the origin of galaxies, of stars, of us. And yet, even this deafening chorus accounts for only a sliver of what the universe truly is. 5%. Just 5% of the cosmos is composed of the matter we can see, measure, and name. The rest is shadow, inferred not from direct detection, but from gravity's stubborn insistence that something is missing. Dark matter, the unseen scaffold of the universe, holds galaxies together like invisible sinew. Without it, spiral galaxies would fly apart. It has no known charge, reflects no light, interacts with no force except gravity. And yet, its presence is undeniable. Vera Rubin first noticed the anomaly when she charted the rotation curves of galaxies. Stars at the edges moved too quickly, far faster than Newtonian physics allowed, as though led in a dance by a partner who could not be seen or touched. That dance, that gravitational grip, became one of the defining riddles of modern astrophysics. Rubin's work revealed the ghost within the cosmic machinery: gravitational lensing. Another piece of the puzzle shows us how light bends more than it should as it passes massive galaxy clusters. The light's path is curved, suggesting hidden mass pulling on space itself. Dark matter, it seems, acts like a transparent lens, warping the very geometry of reality. It's not just what's there, it's what determines how things move, how light travels, how structures persist across time. Some speculate that dark matter might be composed of WIMPs, weakly interacting massive particles that pass through our bodies every second, utterly unnoticed. Others propose actions, hypothetical particles so light and elusive they skirt the boundaries of quantum detection. There are those who whisper about primordial black holes, formed not from stars, but from quantum fluctuations in the earliest moments of the cosmos. Perhaps they float between galaxies, hidden by their very nature. Deep underground, detectors like Xenon and Lux sit in silence, buried beneath kilometers of rock to shield them from the noise of cosmic rays. They wait, for years sometimes, for a single dark matter particle to leave its signature, a brief flash, a recoil, an echo. Nothing so far. But the search continues, because if we can't detect dark matter directly, we must redefine not just cosmology, but the very limits of what it means to measure, to observe, to know. But even dark matter, vast and mysterious as it is, may be only part of the story. At the core of many galaxies, including our own, lurk supermassive black holes, behemoths with masses millions to billions of times greater than the Sun. These are not theoretical curiosities. Their existence has been confirmed through observations of stars whipping around invisible points with impossible speed. In 2019, we saw one with our own eyes, the silhouette of the black hole in galaxy M87 captured by the Event Horizon Telescope. It was not a simple photograph, it was the image of absence. The shape of spacetime torn open, framed by glowing plasma. These objects are where relativity and quantum theory come to war. Their event horizons are one-way boundaries, beyond which even light cannot escape. But inside, we don't know. A singularity, an infinitely dense point lurks there, according to classical physics. But infinite is a word that physics uses only when it's run out of better explanations. What lies within might demand a theory of everything, something that unites gravity with the quantum world. We do not have that theory yet. Around many black holes swirl accretion disks, rings of gas and matter heating to millions of degrees as they spiral inward. These disks emit X-rays, radio waves, and sometimes, astonishingly, jets of particles that erupt perpendicular to the disk and shoot across intergalactic space at near light speed. Matter entering a black hole does not simply vanish, it becomes energy, structure, radiation. It is transformed. Yet even black holes are not eternal. According to Stephen Hawking, quantum effects at the event horizon cause black holes to radiate, slowly leaking energy over vast timescales, a process known as Hawking radiation. Over trillions upon trillions of years, they will evaporate, leaving only a whisper of mass behind. The ultimate fate of matter is not collapse, but dispersal. The universe remembers everything and then lets go. Still, not all mysteries are distant. Not all riddles lie in the dark voids between galaxies. Neutrinos, the universe's shyest particles, pass through us by the trillions each second. Born in nuclear reactions in the Sun, in supernovae, in cosmic ray collisions, they rarely interact with anything. They are nearly massless, ghost-like, and yet, in their elusiveness, they offer a portal into both the smallest and largest scales of nature. They oscillate, shifting between three flavors as they travel, a discovery that forced physicists to reconsider the standard model of particle physics. Their behavior suggests that the universe is not as symmetrical as we once thought. Deep underground detectors, giant vats of water or liquid argon, wait for rare flashes of Cherenkov radiation, the blue glow of a neutrino finally brushing against an atom. And then there are cosmic rays, charged particles from deep space that strike Earth with energies far beyond anything our accelerators can produce. Some come from solar storms, others from supernovae. The most energetic seem to come from active galactic nuclei or gamma-ray bursts. One particle, nicknamed the "Oh my God" particle, carried the energy of a baseball moving at 100 kilometers per hour packed into a single proton. What engine in the cosmos could hurl such a thing across time and space? We still don't know, but we are listening. Above us, between us, beneath our feet. The universe continues to speak not with sound, but with frequency, radiation, motion, and decay. It tells stories of birth and annihilation, of expansion and symmetry broken, And through it all runs a thread, the persistent curiosity of a species small enough to be humbled by the stars, and bold enough to chase them. Imagine for a moment that the sky itself is stretching, not metaphorically but literally, that every second, the very fabric of space between galaxies expands. The galaxies aren't flying through space like shrapnel from an explosion. Instead, the space between them is growing, like dough rising in a loaf of bread. Every galaxy is a raisin, and we on a small raisin called the Milky Way are drifting with the cosmic current. This expansion is not new. It has been happening since the beginning. Edwin Hubble first noticed it in the 1920s when he measured the redshift of light from distant galaxies. The farther away a galaxy was, the more its light was stretched toward the red end of the spectrum. This wasn't a Doppler shift from motion, it was the light being stretched as space itself expanded. This discovery shook the foundation of physics. The universe was not static, it was dynamic, unfolding, breathing. And then, in the late 1990s, we discovered something even more startling. Astronomers studying distant supernovae expected to find that the universe's expansion was slowing down, decelerating under the pull of gravity. Instead, they found the opposite. The expansion is speeding up. Galaxies are not just drifting away, they are accelerating apart. Something unseen, something pervasive, is driving this acceleration. We gave it a name, as we always do when we do not understand dark energy. This mysterious force makes up roughly 68% of the energy content of the universe. It is not matter. It is not light. It is not something we can touch or confine. And yet, it is everywhere, woven into the vacuum itself. The emptier the space, the more dark energy it seems to contain. It is as though nothingness has power, as though the void pushes outward on the universe with relentless force. We have theories. Some suggest dark energy is a property of space itself, a cosmological constant first proposed by Einstein, then abandoned, then reconsidered. Others propose a dynamic field, quintessence, that changes over time. And in the deepest realms of speculative physics, some think dark energy is a sign that we are but one bubble in a foam of universes, each expanding, each governed by slightly different laws of physics. If the expansion continues indefinitely, a lonely future awaits. In 100 billion years, all galaxies outside our local group will recede beyond our cosmic horizon. They will vanish from our view not by moving faster than light in space, but because space itself will be expanding faster than light can travel through it. To observers in the far future, the night sky will be almost empty. The universe will seem small and quiet, even though it is vaster than ever. In more extreme models, the acceleration increases until it tears apart galaxies, stars, planets, eventually even atoms. This big rip is not just science fiction. It's a scenario supported by certain versions of dark energy. Other models suggest the acceleration will slow, or even reverse, leading to a big crunch where the universe collapses back into singularity, or perhaps a big bounce in eternal cycle of expansions and contractions. These ideas are not just metaphysics. They are rooted in measurements of supernovae, of galaxy clusters, of the cosmic microwave background, but the data remains incomplete. The theory's speculative. We are building telescopes, satellites, and detectors not just to photograph the universe but to read its fate. And if space can expand, if it can bend under gravity and ripple under strain, then it can tear, it can fold, it can tunnel. Theoretical physicists imagine wormholes, bridges through spacetime that connect distant points. If real, they could allow shortcuts between galaxies, or even between times. These are not inventions of science fiction, but solutions to Einstein's equations. The math permits them. Reality, so far, has not confirmed them. Wormholes require negative energy, exotic matter that repels instead of attracts. We do not know if such matter exists in stable form, but the idea lingers, tempting, like a trapdoor hidden under the fabric of space. If they exist, they could be the scaffolding of a deeper reality, a cosmic internet connecting distant realms not just across space but across versions of reality. Cosmic strings add another wrinkle. Hypothetical defects in spacetime, thinner than atoms but stretching across galaxies. If they exist, they are scars from the early universe left behind during phase transitions as the cosmos cooled and symmetries broke. like cracks in frozen water. They mark the places where reality changed too quickly to remain smooth. A cosmic string's gravity would be immense. A loop of string the size of a mountain could outweigh entire planets. If one passed between us and a star, it could split the image like a cosmic lens. If two strings collided, they might release a burst of gravitational waves strong enough to shake the Earth. So far, none have been found. But experiments are watching the sky for their signature: a sudden flicker, a peculiar lensing, a whisper in gravitational data. And what if the strings are not just leftovers? What if they are still active, vibrating, looping, shaping the evolution of galaxies, of space-time, of the rules we think are unchangeable? From these ideas emerges something even more audacious: the multiverse. If our universe began with inflation, a burst of exponential expansion, it might be just one bubble in a much larger foam. Other bubbles could form, each with different physical constants. One with no gravity, one with 6 dimensions of space, one where time loops back on itself. In some of these universes, stars may never form. In others, stars may burn eternally. A few might look eerily like our own. And in the grandest versions of the multiverse, every possibility permitted by quantum mechanics is realized somewhere. There is a version of you reading this paragraph in another language, on another planet, under a different sky. It is tempting to dismiss this as fantasy. And yet the same equations that describe our universe whisper of these possibilities. The mathematics does not stop at our event horizon. Even time, that most familiar illusion, may be stranger than we think. Near a black hole, time slows. Near a wormhole, it might loop. In quantum mechanics, the past and future are part of a single wave function, a smear of possibility that only collapses when observed. Some physicists suggest that time is not fundamental at all, that it emerges from entanglement and thermodynamic flow, like temperature from molecules. Entropy, the arrow of time, increases in one direction, but the laws of physics themselves are time-symmetric. In theory, a particle's behavior looks the same whether time moves forward or backward. So why do we remember the past and not the future? Why does cause precede effect? Perhaps the universe began in a state of extremely low entropy, a condition so improbable it demands explanation. Inflation might provide one. Or perhaps, as some suggest, the universe is time-symmetric in total, with two halves, one expanding forward, the other backward from a shared origin. We are simply embedded in one side of the temporal mirror. None of this diminishes the mystery. If anything, it deepens it. We thought we lived in a universe of stars and void. Instead, we find ourselves adrift in a sea of invisible matter, propelled by a force we cannot name, obeying laws we cannot yet unify. And still we observe, we calculate. We build machines to listen for whispers in the dark. A century ago, the idea of other galaxies was radical. 50 years ago, the Big Bang was still debated. 20 years ago, we had never seen a black hole. Science moves slowly, but it moves. Perhaps one day we will confirm the existence of cosmic strings, of wormholes, of dark energy's true nature. Perhaps we will discover that the universe is not a thing, but a process, a self-organizing system without center or edge, governed by laws that emerge from deeper principles we have yet to glimpse. Until then, we look outward and inward. We study the distant quasars and the quantum foam. We listen to gravitational waves and neutrino showers. We stare into the abyss and find ourselves reflected back in it. For in every photon that traveled 1 billion years to reach our eyes, in every vibration of a subatomic particle, in every improbable law that binds entropy and emergence, lies the same message: the universe is alive with possibility. Somewhere, orbiting a distant sun you'll never see with the naked eye, a world turns. Its sky may glow orange. Its oceans might stretch thousands of kilometers deep. Its continents could be frozen, or covered in methane rains, or cloaked in a jungle of alien biochemistry. This world has never seen Earth, and yet it exists, not just in theory but in data, in light, in numbers. A few decades ago, the idea of planets beyond our solar system, exoplanets, was pure speculation. Today, we've cataloged over 5,000 of them. Some orbit stars smaller than our sun, glowing red in the dark. Some whirl around their suns in just hours. Others drift so far from their stars that they are colder than Pluto. We've found super-Earths, mini-Neptunes, lava worlds, and rogue planets wandering alone through the galaxy. How do we see something so small, so far? Mostly, we don't. We infer them. When a planet passes in front of its star, it causes a tiny dip in brightness. That's the transit method. When a star wobbles, pulled gently by an orbiting planet's gravity, its light shifts in color. That's the radial velocity method. These two techniques, refined over years, allow us to detect planets we'll never directly image. The diversity is staggering. Some exoplanets orbit so close to their stars that their surfaces boil, with temperatures hot enough to vaporize rock. On these planets, it might rain molten iron. Others are water worlds, entire planets with deep oceans and no land. A few, like 55 Cancri E, are believed to be composed largely of carbon and may have layers of diamond beneath their crusts. But among this zoo of worlds, one class fascinates us most: Earth-like planets in the habitable zone. Not too close, not too far from their stars. Just right for liquid water to exist on the surface, a necessary condition for life as we know it. One of the most intriguing is Proxima b, orbiting the red dwarf Proxima Centauri, just 4.2 light-years away. It's likely tidally locked, one side always facing its star, the other shrouded in perpetual night. Could life survive in the twilight band between day and night, where conditions might be more temperate? Even more promising is the TRAPPIST-1 system, a compact family of 7 Earth-sized planets orbiting an ultra-cool dwarf star. 3 of them lie in the habitable zone. The entire system could fit within the orbit of Mercury, and from the surface of one TRAPPIST planet. The other 6 might hang in the sky. Larger than the Moon appears from Earth, a cosmic archipelago. Each island a potential home. With the launch of the James Webb Space Telescope, we've taken a major step forward. JWST can analyze the atmospheres of exoplanets by studying the starlight that passes through them during a transit. If we detect certain gases like oxygen, methane, or ozone in the right combinations, they could be biosignatures, hints of life. And yet, so far, we've heard no voice but our own. The silence is profound. Despite billions of potentially habitable worlds, no signal has come. No beacons, no engineered pulses, just the static of nature. This is the heart of the Fermi paradox. If the galaxy teems with worlds, where is everyone? Perhaps we are early. Perhaps we are alone. Perhaps intelligent life is rare, or short-lived, or chooses to remain silent. Perhaps civilizations rise and fall like waves, never overlapping in time. Or perhaps we're not listening correctly. We have scanned radio frequencies for decades, but what if alien civilizations use communication methods beyond our understanding? Quantum entanglement, neutrino beams, gravitational wave modulation technologies we haven't developed yet. We could be surrounded by conversations we simply don't know how to detect. Or maybe life is common, but intelligence is not. Microbial life might flourish in subsurface oceans, under the ice of moons like Europa or Enceladus. These icy worlds, within our own solar system, are among the best candidates for finding life. Beneath kilometers of ice, warmed by tidal flexing from their giant planet hosts, lie oceans possibly teeming with simple organisms. The Cassini spacecraft flew through the geysers of Enceladus and detected organic molecules, carbon-based compounds that are the precursors to life. Future missions will aim to land, drill, taste, because the question is no longer is there another Earth, but how many? And beyond that, what kind of life calls them home? Are they single-celled organisms, photosynthesizing in alien oceans? Are they intelligent creatures with languages, cultures, philosophies? Have they built cities that glow in the night? Or are they like us, just beginning to lift their eyes to the stars? The search is not just technological, it is emotional, philosophical. It challenges our place in the cosmos. If we are alone, then life is rare and precious beyond measure. If we are not, then we are part of something vast and ancient. Either way, the night sky is no longer a mystery of dots. It is a map of possibilities. For centuries, we wondered whether our own planetary system was unique, a solitary jewel amid darkness. Now, we know better. Thousands of exoplanets have been discovered, each orbiting its own distant sun, each a candidate in the grand lottery of life. These planets challenge our imagination. Some are scorched gas giants orbiting within whispering distance of their stars. Others are frozen, lonely worlds bathed in dim twilight. But among them lie rocky planets in temperate zones, places where liquid water could flow, where chemistry could evolve, where life might stir. Imagine watching a star blink ever so slightly every few days. That blink, a dip in brightness, is a planet passing in front. This is the transit method, our most successful technique for detecting exoplanets. Other worlds reveal themselves by tugging gently on their stars, inducing a wobble detected through Doppler shifts in the starlight. These tiny clues, almost imperceptible, have unveiled a cosmic menagerie. We find hot Jupiters, so close to their stars that iron may fall as rain. We find ocean worlds, planets entirely covered in liquid, where no land interrupts the tides. Diamond planets, carbon-rich and compressed into crystalline continents. Super-Earths, larger and denser than our world, may possess thick atmospheres or violent tectonics. What do these worlds mean for life? The answer rests in zones not of politics or economics, but of temperature. The habitable zone around a star is where water can remain liquid, given the right atmospheric pressure. Too close, and oceans boil away. Too far, and they freeze into silence. Within these delicate bands, possibility unfolds. Proxima b, just over 4 light-years away, is a candidate. It orbits a red dwarf, a star smaller and cooler than our sun. One side of the planet may face eternal day, the other, unending night. Could life adapt to such a contrast on TRAPPIST-1's 7 rocky planets? Several reside in their star's habitable zone. Imagine standing on one and seeing 6 other worlds hanging in the sky, an archipelago of potential biospheres. The James Webb Space Telescope is now our eye into exoplanet atmospheres. It searches for biosignatures, gases like oxygen, methane, and carbon dioxide in ratios that hint at biology. Life, if it exists, may not be carbon-based. It may not breathe or metabolize as we do, but it might still alter its world in detectable ways. And what if life is not microbial, but technological SETI? The search for extraterrestrial intelligence listens for patterns that cannot arise from stars or magnetospheres. A structured signal, a repeating pulse, a narrowband radio beam from a distant system, any of these could change our place in the universe forever. But silence persists. Still, this silence isn't absence. It may be latency, or it may be concealment. Advanced civilizations might hide themselves, broadcasting only through methods we cannot yet detect, modulating neutrinos, gravitational waves, or quantum entanglement. The cosmic haystack is vast. We are only now learning to sift its fields. Perhaps intelligence is rare, not because it fails to arise, but because it tends to self-destruct. Nuclear war, climate collapse, runaway AI civilizations may bloom like brief flowers and then vanish. Or perhaps we're early. Perhaps life is just beginning to stir across the cosmos. Now tilt your gaze from potential to history. How did we even get here? The story of cosmic expansion began with Edwin Hubble. He discovered that galaxies are not static, they are fleeing. The farther they are, the faster they recede. It is not that they move through space. Space itself stretches. Like raisins in rising dough, galaxies drift apart as the cosmic loaf expands. This discovery shattered the idea of a steady-state universe. It implied a beginning, a moment when all was compact, hot, and dense. A singular origin, the Big Bang. But expansion had another surprise in store. In the 1990s, observations of distant supernovae revealed that the universe isn't just expanding, it's accelerating. Galaxies are pulling away faster and faster. Some force repulsive, invisible, omnipresent is driving them. We call it dark energy. Dark energy is not a substance we can bottle. It does not clump or swirl. It is more like a pressure built into the fabric of space-time itself. It makes up nearly 70% of the universe's energy content. Yet we do not know what it is. The fate of everything may hinge on it. If dark energy remains constant, galaxies will drift so far apart that each will become a cosmic island, alone in the void. If dark energy grows stronger, it could one day rip apart galaxies, stars, planets, even atoms. This big rip is hypothetical, but terrifying. Or maybe dark energy will fade. Maybe the expansion will slow, halt, reverse, a big crunch, or a big bounce, where a collapsed universe rebounds into another cycle. We measure, we model, we map, but at the heart of the cosmos is a question we cannot yet answer. What is the engine behind the acceleration? We look into the void, and it stares back with silence and speed. Yet not all of space is silent. Some theories whisper of scars, cosmic strings. These are defects in the very fabric of spacetime, formed in the early moments after the Big Bang. Thinner than an atom but longer than a galaxy. These strings could warp light, shake spacetime, emit gravitational waves. They are not strings like in a violin, but strings in the sense of dimensional tiers. If they exist, they could be tools gateways, even to wormholes, shortcuts across space and time, theoretical, speculative, but rooted in the same equations that gave us black holes, neutron stars, and gravitational waves. Cosmic strings could vibrate with energy and vanish in loops. Or they might still stretch across the sky, invisible to our eyes but not to our instruments. We search for their fingerprints in the cosmic microwave background in the way light bends around invisible corners. The dance of existence continues in silence beyond the cosmic horizon. All that has come before black holes, dark matter, exoplanets finds a home in a universe that is still expanding, still evolving. But beyond the phenomena we observe, the deepest questions begin. What gave rise to this universe? And why these laws, these constants, this balance that allows complexity, life, and awareness? In the first trillionths of a second after the Big Bang, something extraordinary happened. Not the explosion itself that's a metaphor, but the rapid swelling of space itself. Inflation. A period when the universe ballooned faster than light, driven by a mysterious energy embedded in the quantum vacuum. During this brief era, quantum fluctuations, microscopic wrinkles in the energy field, were stretched to cosmic scales. They became the seeds of all future galaxies, all future us. These primordial ripples are imprinted in the oldest light we can detect, the cosmic microwave background. It shows us tiny variations in temperature, barely 1 part in 100,000. But those tiny differences determine the shape of the universe to come. Regions slightly denser than average drew more matter, forming stars, clusters, and vast cosmic filaments. The great web of the universe began as a trembling in a quantum field, and this is where theory brushes against the edge of the unknowable. Inflation may not have been a one-time event. Some physicists propose eternal inflation, a bubbling cosmos where each bubble is a universe. Our universe, then, is one among an infinite multiverse. Each bubble may have different physical laws, different particles, even different dimensions. Perhaps, in one, stars never formed. In another, time runs backward. In another, life is silicon, not carbon. These ideas are not just speculative dreams. They emerge from the math that governs the quantum and cosmological realms. String theory, for instance, suggests a universe with 10 or more dimensions, most curled up tightly, beyond our detection. It offers a framework where gravity and quantum mechanics can finally merge. But even if these theories are right, how could we ever test them? What would it mean to peer beyond our cosmic bubble? Could gravitational waves from other universes leave a scar in our sky? Could high-energy particles from a neighboring cosmos punch through the veil? Scientists seek signatures in the sky, unusual cold spots, unexpected alignments, anomalies in the cosmic background that might hint at collisions with other universes. And still, the question deepens. Why is there something rather than nothing? Why these laws, this geometry, this dance of energy and entropy? The anthropic principle suggests we live in a universe compatible with our existence. Others might be barren, short-lived, or chaotic. But this is not a satisfying answer. It begs for more. It hungers for insight. Philosophers and physicists converge here. Some suggest the universe is a mathematical structure, existing because mathematics is inevitable. Others imagine a self-creating cosmos, one that brings itself into being through a loop of quantum cause and effect. Still others invoke the simulation hypothesis that all of this, from quarks to quasars, is information processed in some vast computational substrate. No matter the answer, the search itself is sacred. And so we push forward. We build better telescopes. We refine our theories. We teach our machines to sift patterns from noise. We test the edge of what is knowable. Yet, in the midst of this cosmic ambition, we return to something deeply human. The awe of seeing a sunrise, the touch of a child's hand, the memory of a loved one. These, too, are part of the universe, no less fundamental, no less cosmic. The neutrinos passing through your body right now were forged in stellar cores and supernovae. The calcium in your bones, the iron in your blood, the oxygen you breathe, all made in ancient stars. You are not just in the universe, you are of it. A way for matter to become self-aware, to dream. And dream we must. Of life beyond Earth, of civilizations rising among exoplanets, of technologies that fold space, of messages carried not by light, but by gravitational whispers. The Voyager probes, launched in the 1970s, now drift through interstellar space, carrying golden records etched with music and greetings from Earth. They are tiny ambassadors, drifting farther from us each year, but also closer to eternity. We will go further, with light sails, fusion drives, and maybe someday wormholes. We will seed new worlds, if not with our bodies, then with our minds, our machines, our stories. Perhaps the universe's greatest mystery is not why it exists, but why it allows for beings who can ask why. Beings who can fall in love, grieve, create symphonies, and build particle accelerators. So we end not with an answer, but with an invitation to wonder, to question, to keep listening to the quiet song of the cosmos, knowing that in some subtle way, it is listening back.
In the silent vastness of deep space, where darkness cradles the birth and death of stars, drifts a galaxy unlike any other PGC 100714. From a distance, it appears serene, a luminous ring of pale, uniform stars, suspended like a ripple in the fabric of the cosmos. It is a cosmic artifact, a structure so clean and so precise that it seems to defy the chaotic nature of the universe. It hangs in the void, not as a sprawling, messy spiral or a dense, featureless elliptical, but as a perfect, glowing circle. But a closer examination, a deeper look into its faint light, reveals something far more enigmatic. Unlike most ring galaxies, which are typically defined by a prominent central bulge or a bright, star-filled nucleus, this galaxy lacks a clear core. It is as if its heart has gone missing, or perhaps never existed at all. The very center of this grand structure is a whisper, a faint suggestion of a core where there should be a shout. This central emptiness is not just a physical void, it is a profound and unsettling question written in starlight. PGC 100713 belongs to a rare and mysterious class of galaxies known as Hogue-type objects, or O-type galaxies, named after the astronomer Arthur Hogue, who first described such a structure in 1950. These galaxies are defined by their nearly perfect, detached ring of stars surrounding an isolated, and usually compact, central nucleus. They are among the rarest of all galactic forms, making up less than 0.1% of all observed galaxies. But PGC 1074 is even more peculiar, a true anomaly even within this exclusive club. Not only does it lack the typical bright, compact central nucleus that defines a Hogue-type object, but the ring itself appears unusually detached, giving it the unsettling and almost ethereal appearance of a cosmic donut, floating alone in the vast, empty darkness of intergalactic space. The stars in this outer ring are young, bright, and intensely blue, a clear hallmark of recent and vigorous star formation. However, the origin of this ring, the mechanism that sparked this burst of life in such a perfect circle, remains deeply uncertain. There are no obvious signs of a recent collision, no distorted tidal tails or bridges of stars connecting it to a nearby neighboring galaxy. There seems to be no internal bar structure, a common feature in disk galaxies that can channel gas and trigger ring-like star formation. The usual suspects for the creation of such a dramatic feature are all missing from the scene of the crime. Astronomers believe that ring galaxies are generally the result of a specific kind of galactic collision, a bullseye encounter where a smaller, compact galaxy passes directly through the center of a larger gas-rich disk galaxy. This cosmic punch sends a powerful, expanding density wave rippling outward through the disk, like the ripple from a stone dropped into a still pond. As this wave travels, it compresses the interstellar gas, triggering a wave of star formation in a luminous, expanding ring. But in the case of PGC 1714, such a dramatic and violent explanation feels incomplete, almost out of character with the galaxy's serene and isolated appearance. There is no visible companion galaxy, no characteristic trail of disturbance in the surrounding space, only the quiet, profound silence of an almost perfect circle against the black. The mystery deepens when considering the remarkable symmetry of the ring. Cosmic collisions, even head-on ones, tend to be messy affairs. They create deformed, asymmetrical structures, offset rings, and warped disks. But the outer ring of PGC 1714 is remarkably uniform, a near-perfect circle with its stars orbiting in a well-ordered, coherent loop. It is as if the galaxy has been sculpted with a divine compass, its form too precise to be the result of a chaotic encounter. Some astronomers propose that this galaxy may have formed its ring a very long time ago, perhaps billions of years in the past, and that any evidence of the initial event, the intruding galaxy, the tidal debris, has long since faded beyond our ability to detect it. In this scenario, the galaxy would be a kind of ancient cosmic scar, so old that it has healed into a state of near-perfect symmetry. Others speculate that a rare internal process, one that does not require an external trigger, could have led to this configuration. Perhaps a burst of gas was expelled from an ancient nucleus long ago, or a secular resonance within the galactic disk slowly and gently herded the gas into a ring over eons, leaving only a ghostly halo of young stars and no visible progenitor. Adding another layer of profound curiosity to this cosmic enigma is the presence of a second, fainter inner ring, subtly distinct from the luminous outer one. This nested, two-tiered structure suggests not a single, isolated event, but a complex history with multiple episodes of activity, possibly separated by billions of years of quiescence. The light from this inner ring is redder, indicating that it is populated by much older stars, while the outer ring is intensely blue and clearly much younger. This creates a stratified timeline of star formation, a history written in color, flowing like cosmic tides throughout galactic epochs. What force can create two distinct rings at two different times, with such different properties, all without a prominent central bulge to guide them? PGC 1714 thus becomes more than just a galaxy. It is an enigma written in starlight, a puzzle that challenges our most fundamental models of how galaxies form and evolve. Its central emptiness is not an absence, but a question. Why is there no clear nucleus? What subtle mechanism preserved such perfect symmetry in a universe defined by chaos? Did this galaxy evolve in complete solitude, or was it sculpted by invisible hands, by gravitational encounters now lost to the deep currents of cosmic time? To study such a baffling anomaly, astronomers turn to the power of multi-wavelength observations, scanning the galaxy in visible ultraviolet and infrared light to piece together its story. The data from these surveys confirmed what the eye had already suggested. The outer ring is a site of intense and recent star formation, a cosmic nursery bursting with young, hot, and massive stars, likely less than 130 million years old. These are the ephemeral, brilliant blue giants that burn through their fuel quickly and die young in spectacular supernova explosions. In stark contrast, the inner region, not a traditional dense bulge, but a faint, diffuse, rounded core, hosts a much older, redder population of stars, possibly up to 5.5 billion years old. These are the long-lived, cooler stars that give ancient galaxies their characteristic reddish glow. This stark age difference between the two components confirms that the galaxy did not form in a single, continuous process. Its history is told in at least 2 distinct chapters, separated by a long period of quiet evolution. The outer ring, so recent and so bright, may have arisen after a late, quiet arrival of cold, pristine gas, which then fueled a new generation of stars in a perfect circle around the aging galactic heart. But where could this fresh gas have come from? In such an isolated corner of the universe, one compelling hypothesis suggests that PGC 1714 may have slowly and gently accreted it from its surroundings, from the tenuous filamentous web of intergalactic gas that stretches between galaxies like a cosmic spiderweb. Over vast periods of time, this primordial material, mostly hydrogen, may have spiraled inward, attracted by the galaxy's gravitational pull, and eventually coalesced into a stable, rotating ring. The density of this newly acquired gas would have eventually reached a critical threshold, triggering a synchronized burst of star formation without the need for a violent collision. If this is true, the galaxy becomes a kind of cosmic oasis, a self-sustaining system slowly gathering nourishment from the void to ignite new life, all while preserving its serene symmetry and its profound isolation. There is also the possibility of an ancient merger, one that occurred so long ago that its visible scars have long since faded. Perhaps billions of years ago, a smaller, gas-rich galaxy collided head-on with what would become the core of PGC 1714. This initial violent event could have triggered the formation of the first inner ring of stars, while also disrupting and expelling much of the interstellar gas into a large, surrounding halo. Over the eons, gravity would have worked its slow magic, smoothing out the chaos of the initial collision, allowing the stellar orbits to settle into a more ordered, symmetrical state. Meanwhile, the gas that was thrown out during the merger may have slowly cooled and rained back down onto the galaxy, settling into a new, stable disk far from the center. After billions of years of calm, this newly settled gas could have formed the second outer ring that we see today, a delayed consequence of a cosmic violence that has long since been forgotten by the stars. However, each of these explanations feels like a story with missing pages, a narrative that does not quite fit all the observed facts. No single existing model can fully and elegantly account for all the peculiar features of PGC 1714. Why is the outer ring so clean and free of the distortions and asymmetries that are the hallmarks of galactic interactions? Why is there no residual bar or inner spiral structure, features that are so common in ring galaxies that are thought to be formed by internal processes? Why are the two rings so profoundly different in age and color, yet so harmoniously and perfectly aligned? These are not just questions for astronomers, they are questions about the very nature of cosmic evolution. Galaxies like PGC 1714 offer us precious glimpses into the deep, non-linear, and often surprising pathways of galactic evolution. They challenge our neat and tidy categories of spiral or elliptical, young or old, dynamic or passive. They exist at the very edge of our understanding, inviting us to rethink how galaxies can grow, how they interact with their environment, and how they preserve the memory of their own history. Perhaps the most striking and evocative aspect of PGC 1714 is not its central emptiness, but its profound sense of equilibrium, a cosmic yin and yang of youth and age, of silence and light, of chaos long extinguished, and a strange, quiet order left behind. In a universe that is so often defined by turbulent mergers, collapsing clouds, and spinning, chaotic spiral arms, the quiet perfection of PGC 1017 feels like a deliberate and profound anomaly. It stands alone, not just in the space it occupies, but in the conceptual space of our theories. It is a floating ring with no obvious sculptor in sight, a perfect crime with no suspects. And perhaps that is what makes it so deeply captivating, not what we know about it, but everything we do not yet know. It is a mystery that invites us not to solve it, but to simply be with it, to contemplate its silent, glowing form and the deep questions it raises about the universe and our place within it. The location of the galaxy in the cosmos only adds to its mystique. It is not part of a densely populated galaxy cluster, where gravitational chaos reigns and frequent interactions are the norm. It exists in relative isolation, in a quiet, under-dense region of the universe, far from the violent galactic arenas where ring structures are typically forged. This solitude, this cosmic loneliness, suggests a slow, almost meditative evolution, a process sculpted not by catastrophic collisions with other galaxies, but by more subtle, more elusive, and perhaps more internal forces. It is possible that it is precisely this isolation that has allowed the galaxy's unique and delicate form to persist so immaculately for so long, with no galactic neighbors to disturb its structure, no tidal turbulence to perturb the orderly dance of its stars. PGC 1017 may have been afforded the rare cosmic luxury of stillness, a chance to evolve on its own terms, undisturbed by the noise of the universe around it. This quiet environment, however, raises a profound paradox. If the galaxy is so undisturbed, so free from external influences, how did such a vibrant and youthful ring of stars arise? Star formation is not a passive process. It requires raw material, vast clouds of cold gas and dust, and some form of catalyst to ignite it. In most galaxies, this catalyst comes from the gravitational compression of gas in spiral arms, or from the violent shocks and turbulence generated by galactic mergers. But PGC 1714 shows no spiral arms and no signs of a recent disturbance. The usual suspects for triggering a starburst are all absent. And yet, the stars of the outer ring still shine, intensely blue and defiantly bold, as if they were born from nothing but the pure geometry of the void. There is something haunting about this silent creation, something that speaks to a deeper, less understood mode of galactic life. PGC 1714 challenges our understanding not just of galactic mechanics, but of the very nature of cosmic time, memory, and transformation. In its serene and perfect form, we see the faint echoes of an event that may have once happened, a drama whose actors have long since left the stage, or perhaps an event that never occurred at all in the way we understand it. It is a shape without an apparent cause, a ring without a finger, a wave without a splash. It is a powerful reminder that in the vast and complex history of the cosmos, not every structure is a direct and violent consequence of another. Some forms may be the result of waiting, of slow, invisible processes peeling away layers of chaos over the eons, of a gradual settling into a state of profound and beautiful equilibrium. The absence of a central bulge, the missing heart of the galaxy, becomes a symbol in itself, a resonant silence at the core of the galaxy's being. Most galaxies, like our own Milky Way, hold the bulk of their mass at their center, condensing stars, gas, and a supermassive black hole into a dense, bright, and active heart. But PGC 1714 does the opposite. It expresses itself at its edges. Its life, its vibrancy, its beauty, lives not in its center but in the symmetry of its circumference. It is a galaxy that speaks through absence, through what it holds back rather than what it displays. It is a cosmic minimalist, a structure of profound elegance and restraint. And in that sense, PGC 1071 becomes more than just a peculiar astronomical object. It becomes a question mark inscribed in stars, a structure that resists our attempts at categorization, that defies the neat molds of galactic classification, that whispers of a cosmic order we have not yet grasped. It is at once primitive in its simple, circular form and incredibly refined in its symmetry and balance. It is ancient at its core and newly born at its edge. It is mechanical in its orbital precision and almost mystical in its appearance. It is galaxies like PGC 1071 that serve as crucial reminders that the universe is not simply a system of predictable laws, but also a rich and varied landscape of exceptions. For every model we build, for every formula we write to predict the motion of stars or the growth of galactic disks, there exists a PGC 1007 quietly and elegantly invalidating our certainty with its silent defiance. Its luminous blue ring is not just a loop of incandescent stars. It is a loop in our logic, a beautiful circle drawn around an explanation that we have not yet found. And yet, it is this very mystery that fuels the scientific imagination and drives our quest for understanding. With every puzzling detail, PGC 1071 becomes a natural laboratory for the exploration of new and unconventional theories. Could its unique structure be the result of interactions not with another galaxy, but with the invisible and mysterious dark matter that we know surrounds it? Perhaps unseen substructures within its dark matter, halo filaments or clumps of this unseen mass, have gravitationally guided the collapse of intergalactic gas into a perfect ring, acting as an invisible mold for the visible matter. Or perhaps PGC 1071 is an ancient relic of a different population of galaxies that may have been more common in the early universe, long before the dominance of spirals and ellipticals. It could be a fossilized blueprint of a lost evolutionary path, a survivor from a different cosmic era. Some theorists have even entertained the possibility that its perfect symmetry is an illusion, a trick of the light caused by a rare and precise gravitational lensing event, where the light from a more distant normal galaxy is bent by an intervening massive object into a perfect circle, an Einstein ring. But none of these scenarios, as intriguing as they are, fully captures the strange and serene equilibrium that this galaxy presents: a perfectly proportioned circle, suspended in a profound and lonely solitude, ancient at its core and blooming with new life at its edges. To observe PGC 100714 is to witness a moment of galactic stillness, not a frozen, static moment, but an expectant one, a structure caught mid-thought in the long, unfolding sentence of cosmic time. We may never know the full story of what shaped it, but perhaps the lack of easy answers is not a flaw in the observation. It is an essential part of the experience. This galaxy does not invite us to solve it as a problem, but to inhabit it as a mystery, to orbit its deep silence as its stars do, to consider the profound possibility that some of the most beautiful structures in the universe are not made to be explained, but simply to evoke a sense of wonder. In the end, PGC 100714 is not just a cosmic anomaly, it is a meditation. It is a meditation on form without apparent force, on balance without external pressure, on the rare and precious stillness of a system that does not demand to be understood, only to be witnessed. Amid the constant violence and chaos of galactic dynamics, it is a ring of peace, serene, symmetric, and deeply, profoundly beautiful. And so, PGC 1007 continues its slow, graceful rotation in the dark depths of the southern sky, far from our own galaxy and farther still from our easy comprehension. It does not command our attention with bright, violent outbursts or dramatic interactions. Instead, it persists in a state of quiet, almost regal, elegance, a lone ripple frozen on the surface of space-time. Each stately orbit of its luminous ring is a soft echo of a hidden cosmic history, a luminous question, tracing the very limits of what we think we know. It is a powerful reminder that the universe is not built solely on the typical, the average, the predictable, but is also shaped by the rare, the silent, the anomalous, the elegant irregularities, the whispered exceptions to the rules. PGC 1014 tells us that not all galaxies grow through the chaotic beauty of spiral arms or collapse into the dense, featureless glow of elliptical cores. Some choose to trace their stories along the edge of the void, in the profound symmetry of isolation, in the quiet grace of a ring with no origin we can name. And perhaps that is the truest and most important lesson it has to offer us, that beauty in the cosmos is not always tied to function, that order can arise from silence, and that mystery is not a flaw in our knowledge to be solved, but a space in our understanding to be respected. PGC 100714 does not explain itself, and perhaps it does not need to. It simply is. A luminous enigma drifting at the edge of our understanding, glowing softly, patiently in the dark, in the endless, sprawling ocean of galaxies that populate the observable universe, the chaotic spirals tangled with star-forming arms, the giant ellipticals swollen with ancient red light, and the irregulars scattered like the cosmic debris of ancient collisions. PGC 100714 stands out as a singular, almost contemplative presence. It does not shout for attention with the brilliant glare of a quasar or the violent light of a supernova. It murmurs, its form as subtle and as perfect as a ripple left on a still pond by an unknown event. It moves with a timeless, stately rhythm, an elegant relic of a cosmic process we do not yet understand. And in that profound stillness lies a strange and powerful kind of eloquence. Its circular outer ring, almost mathematical in its precision, glows with the intense, vibrant light of young, hot, blue stars, massive, ephemeral suns burning through their brief and brilliant lives on the very edge of the void. They orbit not a bustling, crowded galactic nucleus, but an ambiguous, quiet, and almost absent center. No elegant spiral arms reach out to gather matter. No dense central sun funnels gas into a cataclysmic starburst. Instead, PGC 100714 embodies a rare and beautiful equilibrium, a system where the outward expression is far more vivid and alive than the inner heart. It is a cosmic architecture that seems to invert the usual logic of galactic evolution, where activity and mass normally collapse inward over time. Here, for reasons we do not yet comprehend, creation has bloomed outward, as if the cosmos decided to paint this particular canvas from the center out, leaving the middle almost untouched. Telescopic observations across the electromagnetic spectrum reveal that the outer ring of PGC 1714 extends almost 130,000 light-years across, a diameter slightly larger than that of our own Milky Way. It is composed of intensely luminous clusters of stars that are remarkably young in astronomical terms, having formed in a synchronized burst of creation. This suggests that the formation of the ring was not a random or staggered process, but the result of a coherent and organized event that swept through the galaxy's outer regions. Yet the lack of visible instigators, no nearby interacting galaxies, no gaseous bridges connecting it to its environment, no obvious debris from a past merger, means that the ultimate cause of this creative event remains deeply, profoundly veiled. Even the inner region of the galaxy, though faint and less structured, tells its own compelling story. Photometric analysis of its light reveals a diffuse, reddish structure, a clear sign of an aging population of stars housed in a spheroidal, almost spherical, distribution. There are subtle hints of a former, now faded ring, or perhaps a fossilized disk, a suggestion that PGC 1714 may have once been a more typical galaxy, a galaxy with a more defined center, perhaps even with spiral arms that have since been lost or transformed into the serene structure we see today. The idea that we are witnessing a single static moment within a much longer and more complex metamorphosis is not just compelling, it is haunting, like a perfectly preserved shell found on a cosmic beach. PGC 1714 may be what remains after eons of silent, invisible tides have washed away the evidence of its past. In many ways, this galaxy acts as a kind of astronomical koan, a paradoxical question or statement that is used in Zen Buddhism to provoke doubt and test a student's progress. It is an unanswerable question designed not to be solved with logic, but to be contemplated until a deeper understanding arises. It exists at the intersection of our neat categories. It is ring-like, but not like the typical collisionally formed rings we are familiar with. It is highly symmetric, but not clearly sculpted by any known gravitational hand. It is isolated from the chaos of the universe. But it is still actively evolving. It is the embodiment of a contradiction, and yet it holds together with such elegance and precision that those contradictions feel deliberate, as if the universe created it specifically to defy our explanations, to remind us of the profound limits of our current models. What does it mean for a galaxy's most prominent and beautiful feature to be its emptiness at the core? What does it tell us about the myriad pathways of cosmic evolution that such a high degree of beauty and coherence can arise without a clear precedent or a visible consequence? PGC 1714 is not just a structure in space. It is a moment in time, a lone, elegant sentence in the epic, ongoing story of galactic history. It may represent a rare and transient phase, a transitional body passing through a state of being that we are only just beginning to recognize. Or it may be a survivor from a long-lost population of galaxies, a living ghost of a galactic species that once thrived in the early universe and now flickers alone on the quiet margins of our vision. Perhaps what makes PGC 1714 so profoundly and enduringly captivating is not just its strange and beautiful structure, but the deep and quiet feeling it evokes, the way it silently demands our attention, like a cosmic artifact too symmetric to ignore and too inexplicable to dismiss. In a universe so often defined by the sound and fury of its most violent processes, by collisions, explosions, ejections, jets, and chaotic spirals, this galaxy offers a powerful and serene counterpoint. It is a whisper in a cosmic storm, a perfect and ordered form where we would expect to find disorder, a ring without a story that we can yet tell. Astronomers have pointed out that even within the incredibly rare class of Hoag-type or O-type galaxies, PGC 1714 is a true and singular anomaly. Hoag's object itself, the iconic and eponymous ring galaxy discovered in the mid-20th century, at least has a dense, bright, spherical nucleus of old, yellow stars anchoring its structure. PGC 1714 does not even have that. Its core is faint, featureless, diffuse, and unassuming, as if the galaxy is deliberately trying to erase its own origin, offering only a minimalist, ghostly sketch of a center where most galaxies would wear a brilliant and heavy crown of mass and activity. It is like stepping into a vast, ancient cathedral and finding the altar missing. And yet the architecture still holds. The silence still speaks with a profound resonance. That central emptiness is not just physically void, it is emotionally and philosophically evocative. It creates a kind of gravitational metaphor we The observers are drawn in by what is not there, much like we infer the presence of black holes by the matter and light that disappears into them. The deep mystery of PGC 1074 lies in its absence, in the tantalizing possibility that something fundamental to its galactic identity has been removed, hidden, or perhaps never even existed in the first place. And then there is the symmetry. In nature, on Earth, and in the cosmos, perfect symmetry is rare, and where it exists, it is often fragile and ephemeral. Perfect snowflakes melt, bubbles burst, and even the most symmetrical living organisms have their slight deviations. Yet this galaxy's outer ring maintains a calm, disciplined, and almost mathematical equilibrium, curving without any noticeable distortion, enclosing a vast region of space in a near-perfect circle. It is hard not to see it as something deliberate, something almost artistic, as if nature itself paused its usual chaotic brushstrokes to draw a single, clean, and perfect line before returning to the messy business of creating the rest of the universe. To imagine how such a structure could have formed is to enter the realm of speculative astrophysics, a place where our models must bend and the data whispers more than it declares. Could it be that PGC 1074 formed not from a direct and violent collision, but from a more subtle and gentle event, the slow, patient accretion of cold, pristine intergalactic gas, forming an annular starburst at just the right distance from a faint and ancient core? Could subtle gravitational resonances, rarely observed and even more rarely sustained over billions of years, have sculpted its stars into place, like a celestial standing wave, a pattern of cosmic music made visible? Or perhaps its perfection is, itself, just a phase, a rare and fleeting moment between more turbulent and chaotic epochs, a galaxy caught in an instant of transformation that will never look quite the same again, like the calm, quiet eye of a hurricane, or the frozen, perfect ring of ripples around a stone that was dropped into a pond long ago. PGC 1074 may be suspended in a state of temporary, beautiful serenity before the inexorable forces of entropy and gravitational dynamics return, and its delicate structure begins to unravel into something more common, more disordered, whatever the cause. This galaxy has become more than just a case study for astronomers. It has become a symbol of cosmic patience, of improbable order, of a form of evolution that is not driven by violence, but perhaps by stillness. And in that role, PGC 1074 transcends its celestial coordinates and its dry technical classification. It is no longer just a galaxy, it is a mirror held up to the cosmos, reflecting not just starlight, but the profound depth and hunger of our own curiosity. Let us now delve deeper into the poetic architecture of the cosmos, where an object like PGC 1074 no longer belongs just to the realm of science, but also to the philosophy of the night sky. In a universe that is governed by the inexorable arrow of time and the second law of thermodynamics, where everything tends toward disorder and chaos, PGC 1074 seems to momentarily and beautifully pause that inevitable fall. It is an act of perfect balance in a sea of cosmic imbalance, a geometric and elegant negation of the universe's inherent tendency towards entropy. It holds itself together like a memory that refuses to fade, delicate, quiet, but unmistakably, profoundly present. Time may move around it, stars may be born and die within its luminous orbit, but the perfect ring remains, turning slowly and silently around a center that offers no clear explanation for its own existence. And perhaps that is its deepest secret. It embodies the concept of memory, but not the kind of memory that we can easily archive or understand, not the kind that is found in data or images alone. PGC 1074 is a memory without a narrator, a structure left behind by an event whose witnesses are long gone, whose ultimate cause is lost to the deep past, and whose consequences are still gracefully unfolding before our eyes. It is the silent visual echo of a song that we cannot hear, preserved for us only in the ancient language of light. In this way, this distant galaxy becomes a powerful metaphor for much more than just astronomy. It becomes a meditation on the nature of identity itself, both galactic and human. Who are we when we no longer remember how we came to be? What remains of a structure when its very core has been removed or has faded into obscurity? Can a form exist without a clear function? And can beauty exist without an obvious purpose? PGC 1714 seems to answer these profound questions, not with words or with data, but with its simple, elegant, and undeniable presence. It simply is. We, the observers, orbit it not with spacecraft and probes, but with our thoughts and our imagination. Our telescopes, extensions of our own curious eyes, capture its faint and ancient photons, particles of light that have been traveling across the void for hundreds of millions of years to reach us, light that left the ring long before we walked the earth, before the first mammals arose, before the continents on our own planet had drifted into their current shapes. And yet, that ancient light arrives now, perfectly on time, to our waiting instruments and to our hungry imagination. We behold it from across the vast, dark gulf of spacetime, and in doing so, we participate in a cosmic act of recognition, a meeting of minds across an almost unimaginable abyss. This silent, distant galaxy reminds us that not all of the universe's truths shout. Some are written in the silence between the stars. Some are drawn in the darkness of the void. Some galaxies burn with the brilliant, violent activity of their cores, birthing stars by the billions and tearing apart their cosmic companions in fits of gravitational fury. But PGC 1714 does none of that. It does not burn with a fierce fire. It glows with a soft, cool light. It does not speak in a loud voice. It endures in a quiet whisper. And perhaps that is its final and most profound message for us, that not everything in the universe is urgent, that some things, like this pale, perfect, and lonely ring, are meant to be noticed slowly, understood only partially, and remembered fully, not just for what they are, but for the sense of wonder they inspire. Let us let the mystery of this galaxy linger a moment longer, not in an attempt to solve it, but simply to honor it. Because perhaps PGC 1714 is not meant to be deciphered like a complex mathematical equation, but to be experienced like a profound and beautiful poem. Its luminous ring, glowing faintly in the deep abyss of space, becomes a single, perfect stanza, written for us in the ink of starlight. Each of those brilliant blue stars is a syllable in a language far older than humanity, older than the Earth itself, older even than the familiar, grand spiral galaxies that dominate our night sky. To look at it is to briefly and humbly touch the immense patience of cosmic time. It is not an answer to our questions, but a pause, a cosmic breath held in the deep, silent lungs of the universe. And that quiet pause invites us, in turn, to stop our own frantic search for answers, to listen to the silence, and simply to wonder. In our relentless rush to measure, to model, and to categorize, PGC 1714 gently whispers, stillness. In our deep-seated hunger to classify and to label, it offers a form that slips through the fingers of our taxonomies like light through empty space. And in the constant, deafening noise of a universe that is expanding without end, it speaks of something incredibly rare and precious: completeness without chaos, form without apparent force, and existence without the need for an explanation. Somewhere within the dark and silent cathedral of the cosmos, where the distant galaxies flicker like the light of 1,000 stained glass windows, In the vast, profound hush of intergalactic space drifts a perfect ring of light, a structure of both burning creation and ancient memory. PGC 10714, no name, no classification, could ever fully capture what it is. Not fully, not really. It is more of a symbol than an object, more of a question than an answer. It is like a wound in space-time that has healed into a perfect, glowing circle, and the longer you gaze upon it, the more it begins to feel like the universe itself is trying to say something to us. Not with force, not with clarity, but with a quiet and profound grace. Because this galaxy is not chaotic. It does not unfold its stars in arms thrown wide like dancers in ecstatic motion. It does not roar with powerful jets of matter or burn with the intense heat of colliding galactic giants. It is calm, it is perfect, it is measured. It is a single luminous ring glowing against the deep and velvet dark, as if a god had drawn a circle in the night with a single glowing fingertip, and then, without a trace, disappeared. That ring, so impossible and so beautiful in its symmetry, is made of young, intensely blue, brilliant stars, newborns in cosmic terms, burning hard and fast and destined to live short lives. But unlike most ring galaxies, there is no majestic, bustling center, no crowded and luminous galactic nucleus to draw the stars inward with its immense gravity. Instead, there is only a faint, diffuse glow at its core, a whisper of a memory long after the voice that spoke it has gone silent. The eye, trained by observing thousands of other galaxies, expects to find a heart, but in this galaxy, the heart is missing. Or perhaps it is just hidden from our view. This central paradox, this emptiness at its core, is what gives PGC 10714 its profound and mysterious power. It is not just strange, it is quietly, elegantly strange. It does not baffle our senses with violence and chaos. It seduces our minds with its silence and its order. It is the kind of mystery that does not announce itself with a loud bang. You have to notice it. You have to be still long enough for the deep and quiet question to emerge from the darkness. How could such a perfect and lonely form ever arise? We know that rings in galaxies often mean collisions, dramatic, head-on crashes where one galaxy punches through the very heart of another, sending powerful ripples of compressed gas and dust through its stellar body, a process that ignites a wave of new star formation in a brilliant, expanding ring. But here, in the case of PGC 17714, we find no debris, no gaseous bridges, no second galaxy, no cosmic smoking gun. There is just this, a newborn circle of burning light, wrapped around an ageless, almost centerless core, suspended in the void, untouched, whole, and profoundly alone. And if it was not formed in a moment of cosmic violence, some theorists have suggested that this beautiful ring may have formed gently, through the slow and patient accretion of cold, pristine gas from the intergalactic medium, that vast, invisible sea of hydrogen that lies between the galaxies. Over hundreds of millions of years, that primordial gas could have gathered and cooled, slowly spinning up to form the stable, star-forming ring that we see today, a structure cradled by the invisible hands of dark matter and sculpted by the pure mathematics of symmetry. In this peaceful vision, PGC 17714 is not a cosmic scar, it is a cosmic flower, a rare and beautiful blossom blooming in the near-perfect vacuum of intergalactic space. But even that elegant explanation does not fully explain everything we see, because PGC 17714 does not have just one ring, it has two. The inner ring, fainter, older, and redder in color, is like a ghostly, silent echo of the brilliant and youthful outer one. This layered, nested structure suggests an even deeper and more complex mystery, not one moment of creation, but two. Not a single isolated event, but a long and complex sequence. as if this galaxy has somehow managed to reinvent itself through the deep river of cosmic time. As if in its profound loneliness, it has learned to sing in multiple harmonious voices, a brilliant blue for its youth, a soft red for its age, a perfect harmony in its form. We do not know what it is becoming. We barely know what it is. But we do know this: it is rare, impossibly, beautifully rare. Among the hundreds of billions of galaxies that we have observed, only a handful display this kind of coreless, double-ringed symmetry, and fewer still are so profoundly isolated, so completely free of any outside interference. In a cosmos that is so often governed by the brutal laws of gravitational wars, this galaxy seems to have chosen a path of peace, and yet there is a profound tension in that peace, a beauty that is born not of ease, but of a quiet and powerful endurance. Because to remain so untouched, so perfect, in a violent universe is itself a monumental feat. It suggests a hidden strength, a quiet resilience, a way of being in the universe that we are perhaps only just beginning to understand. PGC 1014 is not just a galactic curiosity. It is a cosmic koan. It is compact, it is resonant, and it is almost infinite in its implication. It reminds us that even in the coldest and most desolate voids of space, wonder can bloom. That not all of the universe's stories are told with loud explosions and violent collisions. Some are traced in silent, perfect circles. Some only speak when we take the time to listen to the quiet. And some are still gracefully and mysteriously unfolding. And perhaps we, from our small blue world, drifting under the light of our own star, were meant to witness this strange and beautiful galaxy, to record its light, to wonder at its form, to remember its existence, not just as scientists seeking answers, but as a small piece of conscious matter, briefly awake in a vast and silent universe, looking out across the abyss of time at a perfect and enigmatic mirror made of stars. To understand the unique structure and complex history of PGC 1714, astronomers must rely on a careful and multifaceted approach, combining detailed photometry, which is the measurement of the brightness and color of its light, with spectral energy distributions, which break that light down into its constituent wavelengths, and sophisticated dynamical modeling, which attempts to simulate its motion under the laws of gravity. What makes this particular galaxy so profoundly fascinating to scientists is that it challenges several of our fundamental and most cherished ideas about how ring galaxies form, evolve, and are maintained over cosmic timescales. Traditionally, ring galaxies are associated with violent and specific gravitational interactions, typically a head-on, bullseye collision where a smaller, compact galaxy passes directly through the disk of a larger one. This dramatic process generates powerful radial density waves, like the ripples spreading from a stone dropped into a still pond. These waves travel outward through the larger galaxy's disk, compressing its reserves of gas and dust, and triggering a massive, synchronized burst of star formation in an expanding, luminous ring. But in the case of PGC 1714, we see none of the telltale signs of such a catastrophe. There is no visible intruder galaxy in its vicinity, no faint streams of stars torn from the interacting galaxies, no warped or distorted disk, no tidal tails. The ring is too clean, too quiet, too perfect. The observational data we have gathered so far suggests that a much more subtle and delicate process might be at play in the formation of this remarkable object. A strong and leading candidate is a process known as cold mode accretion, the slow, gentle, and continuous inflow of pristine hydrogen gas from the vast and tenuous intergalactic medium. In the cold, dark voids between the galaxies, primordial hydrogen, left over from the Big Bang, flows along immense, invisible filaments of dark matter, forming the cosmic web. If a galaxy is isolated and gravitationally stable, like PGC 12740 appears to be, this intergalactic gas can slowly settle into orbit around it, cooling and condensing over hundreds of millions of years. Eventually, this accreted gas could form a stable, rotating ring, and when its density reaches a critical point, it could ignite a wave of new star formation. This scenario could elegantly explain the young, intensely blue stars of the galaxy's outer ring, all of which appear to have formed relatively recently. Astronomers estimate their age to be within the last 130 million years. Meanwhile, the faint inner region of the galaxy tells a much older and quieter story. Photometric analysis of its light reveals a diffuse, reddish structure, a clear sign of an aged stellar population, with stars that are likely more than 5.5 billion years old. This stark contrast in age and color between the inner and outer rings is extremely rare and provides strong evidence that PGC 1714 went through at least two distinct and well-separated evolutionary phases, a long, passive, and ancient history, followed by a recent and dramatic rejuvenation at its edges. This kind of double ring structure invites other, more complex theories, particularly those involving orbital resonances. These are specific radii within a galactic disk, where the orbital periods of the stars and gas are in a simple integer ratio with the rotation of some large-scale pattern, like a central bar. These resonances can cause gas and dust to accumulate at those specific locations, leading to the formation of rings. In typical spiral galaxies, a central bar acts as a powerful dynamical engine that can funnel gas toward the center of the galaxy, triggering starbursts, or can create ring-like structures at its resonance points. But in PGC 1714, there is no visible central bar. If one ever existed, it must have long since dissolved, leaving only its faint, ghostly gravitational fingerprints behind in the form of these two rings. Another crucial factor in maintaining the pristine symmetry of this galaxy is likely the nature of its dark matter halo. All galaxies are thought to be embedded in massive halos of this invisible dark matter, which govern their large-scale gravitational behavior. In the case of PGC 714, a perfectly spherical, or at least highly axisymmetric dark matter halo could act as a stabilizing force, preserving the ring's orderly, circular motion and preventing it from warping or fragmenting over cosmic time. This would also help to explain the striking absence of the asymmetric distortions and tidal features that are so typical in collisionally formed ring galaxies. High-resolution spectroscopy could shed much more light on this enduring mystery. By creating a detailed map of the rotational velocities of the stars and gas within the ring, astronomers could determine if its motion is purely circular, which would support a quiescent formation model, or if it contains traces of elliptical or radial motion, which would be a telltale sign of a past gravitational disturbance. So far, such detailed data is limited due to the galaxy's great distance and its intrinsic faintness. But future instruments like the Extremely Large Telescope and other next-generation infrared observatories could provide the necessary precision to resolve these subtle motions. There is also a rich chemical story hidden in the galaxy's light. If we could resolve the metallicity gradient across the galaxy, that is, the abundance of elements heavier than hydrogen and helium, we could learn how chemically enriched the star-forming gas was. A low metallicity in the outer ring would be strong evidence for the cold gas accretion theory, suggesting that the gas is pristine and has come from the intergalactic medium. In contrast, a higher metallicity might point to internal recycling processes, or to the reaccretion of gas that was ejected from the galaxy in a much earlier epoch. Taken together, All these lines of evidence present PGC 0714 not just as a beautiful rarity, but as a true and unique cosmic laboratory, an exceptional case study in the long-term evolution of a galaxy in a state of profound isolation, far from the disruptive influence of major cosmic structures. It challenges our standard understanding of how galaxies can evolve and whether stable and dramatic ring structures can form without the need for violent collisions. And that fundamental question has implications that go far beyond this one single strange object. It speaks to the true diversity of galactic forms and evolutionary pathways that are possible throughout the vast expanse of cosmic time. PGC 0714 is not just visually unusual, it is a profound astrophysical anomaly that rigorously tests our most fundamental models of galaxy formation and evolution. Its near-perfect, luminous outer ring of young blue stars, combined with its faint, older central region that completely lacks a defined, bright bulge, places it firmly outside our standard classification systems for galaxies. It does not resemble a familiar spiral, with its chaotic and beautiful arms. It lacks the dense, featureless, and often overwhelming core of a typical elliptical galaxy, and it shows none of the telltale chaotic signs, the warps, the tails, the bridges, that are normally associated with the aftermath of galactic collisions. And yet, against all odds, it exists serene, symmetric, stable, and glowing with a quiet internal light. Multi-wavelength observations, from the high-energy ultraviolet to the cool infrared, have allowed us to piece together a complex and fascinating stellar history for this object. The outer ring is populated by hot, massive, and short-lived stars, suggesting a recent and powerful burst of star formation, an event that likely took place within the last 130 million years. In stark contrast, the diffuse reddish core hosts a much older population of stars, with an estimated age of over 5.5 billion years. This dramatic duality implies a two-phase formation process, a long, quiet, ancient epoch, followed by a sudden and spectacular rejuvenation at its outer edges. But where did the vast reservoir of gas needed to fuel this new generation of stars come from? The usual explanation for the formation of ring galaxies involves head-on collisions that generate powerful density waves, compressing the interstellar gas into star-forming rings. But, as we have seen, PGC 0714 shows none of the typical and expected residuals, no tidal tails, no structural disturbances, no nearby companion galaxy that would point to such a violent encounter. Its profound isolation in the cosmos reinforces the idea that it must have had a more subtle and gentle origin, perhaps through the slow and patient accretion of cold, pristine gas from the intergalactic medium. In this peaceful scenario, the galaxy would have slowly gathered primordial hydrogen over hundreds of millions of years, cooling it and settling it into a stable, rotating disk. The conditions within this new disk would then have been just right to ignite a synchronized ring of new stars at a specific, stable radius. That radius might be governed by fundamental stability thresholds, such as the Tumra-Q parameter, a measure that determines when a rotating, self-gravitating disk of gas will become unstable and collapse to form stars. The presence of two distinct and concentric rings adds another and even deeper layer of complexity to this already profound puzzle. The inner ring appears to be much older and redder, while the outer ring is brilliantly young and blue. This may indicate the occurrence of multiple distinct gas accretion events, separated by billions of years of cosmic time, or perhaps it is the result of complex resonance phenomena within the galactic disk that have shaped the gas into rings at different times. It is possible that the galaxy once had a weak central bar, a very common feature in disk galaxies. which has since dissolved and faded from view, leaving behind only its gravitational imprints in the form of these concentric ring structures. To distinguish between these possibilities, we would need to map the kinematics of the system in great detail, to see how the stars and the gas are moving, whether the two rings rotate in the same direction, whether their motion is perfectly circular or shows signs of elliptical distortion, and whether there are any subtle signs of internal torques or non-circular motions that would hint at a more complex history. Unfortunately, such detailed spectroscopic data is still scarce. Due to the galaxy's extreme faintness and great distance, future observations with the next generation of more powerful instruments could, and likely will, fill in these crucial gaps, providing us with precise velocity fields and detailed metallicity profiles. If the chemical abundance or metallicity of the outer ring is found to be very low, it would be strong support for the cold flow accretion theory, suggesting that the gas is pristine and has not been enriched by previous generations of stars. If, on the other hand, the metallicity is found to be high, it could point to more complex internal processes, or the reaccretion of ancient, enriched gas that was expelled from the galaxy long ago. Either result would fundamentally reshape our view of how galaxies can evolve in a state of profound isolation. Far from the violent and crowded environments of galaxy clusters, dark matter also likely plays a crucial and stabilizing role in this story. The clean, undisturbed, and perfect symmetry of the outer ring implies a very well-balanced and smooth gravitational potential. If the galaxy is embedded in a smooth, spherical dark matter halo, this would help to preserve the ring's delicate structure over immense periods of time, minimizing any distortions. If that dark matter halo were triaxial or clumpy, we would expect to see signs of warping or instability in the ring. The fact that we do not see such features suggests that the galaxy sits in an unusually harmonic and peaceful gravitational environment. Statistically, galaxies like PGC 1714 are extremely rare, Hoag-type or O-type. Galaxies make up less than 0.1% of all known galactic systems, and those with double rings and no bright, defined nucleus are rarer still. But it is precisely in these strange and beautiful edge cases, these outliers, that science often makes its greatest leaps forward. They act as natural and unique experiments, testing the absolute limits of our current models and reminding us, with a profound humility, that not all galaxies follow the same expected evolutionary path. In this sense, PGC 1714 is more than just an anomaly. It is a window into the possible, a glimpse of what can happen when time, gravity, and gas meet in a state of perfect and perhaps temporary stillness. Its profound silence is an essential part of its message. In a universe where galaxies are so often formed and shaped through violence, through chaotic mergers, through the tidal stripping of their stars, through cataclysmic collisions, PGC 1714 seems to have grown with a profound and otherworldly patience. There is no evidence of close companions, no intergalactic debris fields, no long, drawn-out tidal arms or stellar streams that would betray a recent or ongoing interaction. It is surrounded by a vast and quiet emptiness, and yet its form is so precise, so ordered, that it demands an explanation beyond the ordinary. This very isolation may, in fact, be the key to its long-term survival and its pristine form, with no galactic neighbors to disturb it, no gravitational harassment from some surrounding systems to disrupt its delicate balance. It has been able to preserve a kind of galactic purity, an architectural clarity that would be almost impossible to maintain in the denser and more violent environments of galaxy clusters. If we could use a cosmic time machine to fast forward to its distant future, it is unclear what path it would follow. will the beautiful blue outer ring persist for billions of years, slowly fading from a brilliant blue to a dim red as its stars age and die, eventually leaving behind only a faint, ghostly halo of ancient light? Or will new, pristine gas accrete onto the galaxy once again, giving rise to a third generation of stars, perhaps forming yet another, even more exterior ring? That remarkable possibility would turn PGC 1714 into a kind of stratified, living time capsule, a galactic tree ring recording each distinct era of its creative activity in ever-expanding circles of luminous light. Its structure would then be a visual history not of destruction and chaos, but of quiet, cyclical rebirth through the patient accumulation of matter from the void. Studying this strange and beautiful galaxy could also shed new light on the nature of the very early universe. If the slow and gentle accretion of gas from the cosmic filaments can produce such dramatic and ordered ring-like star formation in isolated environments, then perhaps such galaxies were much more common in the distant past. When cold, pristine gas was far more abundant, and the rate of galactic mergers was lower in certain quiet regions of the cosmos. In that sense, PGC 1714 might not be merely a modern-day rarity, but a living fossil, a contemporary representative of a galactic formation mode that is now all but extinct, save for a few exceptional and lonely survivors like this one. It could be a blueprint for a lost and forgotten evolutionary path for galaxies. It could also have profound philosophical implications for how we define and categorize a galaxy. Most of our definitions are based on a galaxy's morphology, its mass or its stellar population. But PGC 1714 seems to resist all of our simple labels. It has no spiral pattern, no central bulge, no active nucleus. And yet, it is an organized and coherent system, a self-contained gravitational and stellar entity with its own long and complex history. Perhaps it demonstrates that the boundaries we draw between ellipticals, spirals, lenticulars, and rings are not as fixed and as meaningful as we believe. Maybe the form of a galaxy is more fluid and more transient in the deep river of cosmic time than any of our static classification systems can ever hope to capture. The more we study galaxies like this, the more we are reminded that cosmic evolution is not a single linear story. It is a branching, cyclical, and often recursive process, where profound symmetry can arise from deep silence, and where breathtaking beauty can emerge from the very absence of chaos. PGC 1714 is a living contradiction, a galaxy that should not be so pristine, and yet it is. A ring of brilliant young stars that should be unstable, and yet it persists. A structure that should reveal the cause of its own creation, and yet it keeps its deepest secrets hidden. It invites our observation, but it does not offer easy conclusions. It invites our most profound questions, but it offers no simple answers. And in doing so, it becomes more than just an object of scientific study. It becomes a phenomenon to be experienced, a cosmic structure that, like the universe itself, offers more than we can ever hope to measure and far, far more than we can yet understand. Instruments like the James Webb Space Telescope and the future ground-based Extremely Large Telescope offer us unprecedented new opportunities to decipher the silent and beautiful enigma of PGC 714. With their extraordinary infrared sensitivity and their ability to resolve incredibly fine spectral features, they can peer deeper into the heart of this galaxy's structure than ever before. The Webb telescope, in particular, with its ability to see through the obscuring veils of cosmic dust, can map the stellar populations and the dust content in both the outer and the inner rings with incredible precision. It can reveal whether the younger stars of the outer ring formed in a gas-rich, dusty molecular environment, or from more pristine, metal-poor material. If Webb's sensitive instruments detect subtle gradients in the emission from polycyclic aromatic hydrocarbons, which are complex organic molecules, or from warm dust, it could confirm the presence of faint but active star formation that was undetectable in previous, less sensitive surveys. It could also provide precise constraints on the metallicity of the gas in the rings, a chemical fingerprint that could unlock the secret of the ring's origin. A flat and low metallicity profile across the outer ring would be a strong indicator of the smooth accretion of cold, primordial gas from the external environment. A radial gradient in metallicity, on the other hand, would suggest a more complex history of internal recycling of enriched gas from previous generations of stars. Meanwhile, the ELT and other planned 30-meter class ground-based observatories will make it possible to study the kinematics of the individual stars and gas clouds within the ring, measuring the velocity field with high precision at thousands of different points. This would allow us to answer fundamental questions about the galaxy's dynamics, whether the ring rotates like a solid, rigid body, whether it shows signs of radial expansion or contraction, or whether it follows a more complex and subtle orbital configuration. Such detailed data would allow us to build much more accurate models of not only how the ring may have formed, but also how it has managed to remain so remarkably stable over hundreds of millions of years. Another exciting possibility is the detection of faint hydrogen gas structures in the vast space around the galaxy, using the next generation of powerful radio observatories, such as the Square Kilometre Array. If extended, faint hydrogen tails, filaments, or inflow streams are detected in the galaxy's immediate vicinity. It would offer direct smoking gun evidence of intergalactic gas feeding the galaxy, a clear confirmation of the source of the fuel for its ring of fire. These structures, if they exist, would be far too faint and diffuse for previous radio surveys to have detected, but modern instruments with deep integration times could reveal them in exquisite and game-changing detail. PGC 1014 could also become a template, a kind of astronomical archetype, for identifying similar systems at high redshift in the early universe, a time when cold gas was much more abundant and the universe was more conducive to smooth accretion rather than chaotic mergers. By using the deep field capabilities of the James Webb Space Telescope to search for other coreless, companionless ring galaxies in the early universe, astronomers might be able to uncover a whole hidden population of proto-O-type systems, the young, formative versions of what PGC 1714 represents today in its mature and evolved state. Such a discovery could fundamentally change the way we think about the life cycles of galaxies. While the dominant narrative of galaxy evolution has long focused on the idea of hierarchical mergers and violent structural transformations, galaxies like PGC 1714 suggest that alternative, more peaceful evolutionary paths might exist, paths that are shaped not by collision and chaos, but by slow, patient accumulation, by subtle internal resonances, and by the profound peace of a quiet cosmic environment. These paths may be rare in the universe today, but in the ancient cosmos, they could have played a crucial and previously unrecognized role in forming the rich diversity of galactic structures that we now observe. In this sense, PGC 1714 is more than just a beautiful curiosity. It is a potential cosmological Rosetta Stone, a key that could help us to unlock the secrets of these quiet formation processes that often go unnoticed in the face of more dramatic and violent galactic events. If we can learn to read the language of its rings, its perfect symmetry, its complex chemistry, its subtle motion, we may discover a hidden grammar of galactic construction, a set of rules that operates outside our usual understanding. And while all of this scientific inquiry happens, the galaxy itself continues to drift, turning slowly and silently in a quiet corner of the cosmos, its ancient light still arriving at our world after crossing hundreds of millions of years of empty space. Each of those photons is a message from the deep past, a tiny fragment of a grand and beautiful story that we are only just beginning to comprehend. The faint light that we receive from PGC 1071 is a time capsule, a stream of ancient photons that began their immense journey long before human civilization existed, long before the continents of our own Earth took their present shapes, long before our own species even emerged from the plains of Africa. Every single piece of data that we gather from this distant object is a fragment of a history that has already been written in the language of stellar motion, of chemical gradients, and of a profound and mysterious gravitational equilibrium. And yet, it is only now, in this brief moment of our own existence, that we are learning to read that ancient and beautiful history. One of the most fascinating frontiers in the study of that history lies in the idea of galactic memory, the profound notion that a galaxy's present-day structure, its morphology, its kinematics, and its chemistry encodes the entirety of its long and complex history. In most galaxies, like our own spiral galaxy, that memory is often chaotic, overwritten, and scrambled by a long history of mergers, warps, and violent starbursts. But in an object as pristine and as ordered as PGC 1071, with the clarity of its rings, the smoothness of its core, and the stark contrast between its stellar populations, it seems more like a perfectly preserved fossil, a clean, clear, stratigraphic record of cosmic time, written for us in the elegant script of light. If our most sophisticated cosmological simulations could manage to recreate such a unique and beautiful structure, not just visually, but dynamically and chemically, they could help us to isolate the precise and rare initial conditions that make such an object possible. Large-scale cosmological simulations like Illustris, Eagle, and TNG-50 attempt to model billions of years of galactic evolution under the standard model of cosmology, which includes dark matter and dark energy. However, extremely rare and pristine ring galaxies, like PGC 1071, very seldom appear in these simulations in such a perfect form. This suggests either that the specific initial conditions required to form such a galaxy are so exceptionally rare that they are not captured in the simulated volumes, or, more intriguingly, that our current models of galaxy formation are missing some crucial and subtle physical processes, perhaps the effects of low angular momentum, gas flows, or non-merger-driven instabilities, or the complex interplay of feedback-regulated accretion over giga-year timescales. Perhaps what PGC 1714 truly represents is a kind of transitional state, a galaxy caught in a moment of transformation that is so slow, so stable, and so graceful that we are only able to detect it by looking deep into the past. It may not always have been a ring galaxy, it may not always be one. But in this particular phase of its long life, with its sharply defined outer structure and its ancient, diffuse inner core, it represents a unique window into a state of profound galactic equilibrium, a state where internal forces, angular momentum, and a quiet external environment have all converged to produce a moment of near-perfect and beautiful balance. That delicate balance may not last forever. The brilliant, young, blue stars in the outer ring are massive and short-lived. They will age quickly, and over the next few 100 million years, they will one by one explode as spectacular supernovae, leaving behind a graveyard of neutron stars and black holes, and enriching the surrounding interstellar medium with heavy elements. If no new pristine gas arrives to reignite the process of star formation, the brilliant blue ring will slowly fade, its vibrant light giving way to a dimmer, redder glow as it's remaining. Smaller stars grow old. Over billions of years, the elegant ring structure itself could dissolve, its stars slowly dispersing due to subtle gravitational interactions, eventually leaving behind only a diffuse and ghostly halo of ancient stars, a faint memory of the perfect form it once had. In this sense, we may be witnessing a fleeting moment of supreme galactic beauty, a delicate and transient structure that exists only in a brief and quiet interlude between a forgotten past chaos and a slow, inevitable future oblivion. This transience, however, does not diminish the galaxy's deep mystery. It only deepens it. It reminds us that the universe is not a static museum of unchanging objects, but a dynamic and ever-evolving landscape of complex and beautiful processes. The galaxy PGC 177 becomes, then, something more than just an object of scientific study. It becomes a profound lesson in cosmic perspective. It teaches us that to truly understand the cosmos, we must look not only at the violent, the chaotic, and the dramatic events, but also at the quiet, the ordered, and the long-lived. It teaches us that absence can be just as informative and as meaningful as presence, and that the emergence of perfect symmetry in a universe that is fundamentally chaotic is one of the most profound and beautiful statements that nature can ever make. And it teaches us that, despite our most powerful telescopes and our most sophisticated models, the universe always reserves the right to surprise us, to present us with a perfect, glowing ring in the middle of the darkness for no apparent reason other than that it can